Hello, and welcome to the channel. Tonight, returning our gaze upward, toward that silent, glowing companion that hangs in the sky like a silver guardian, the moon. But she is more than a distant light. She is a force, a quiet ruler, pulling oceans, stirring winds, guiding rhythms of life in ways we rarely see, but always feel. How does the moon control the earth? With no voice, no hands, no commands. She moves mountains of water, whispers to tides, and tugs gently at the very balance of time. It's a beautiful paradox. Content as rich and fascinating as this, meant to lull you gently into sleep. But here curiosity and calm walk hand in hand, and sometimes the softest answers come when we're just about to close our eyes. If this peaceful place brings you comfort or wonder, we'd be so grateful if you liked or subscribed. It keeps this quiet little universe glowing, one listener at a time. And if you're still awake, drop a comment below, tell us where you're listening from or what time it is where you are. It's always a joy to see our sleep sanctuary stretch across continents from moonlit coastlines to snowy window panes. Now take a deep breath in and let it out slowly. Unclench your jaw, feel your hands grow heavy. Let your thoughts soften like clouds drifting across a midnight sky. You're safe here. You're still, and as the moon keeps watch above, we'll begin our quiet journey into her unseen power, how she gently, endlessly, guides the earth in her silent embrace. The silent ruler in the sky. Picture yourself standing on a quiet beach at midnight. The waves roll in with hypnotic regularity, and overhead, that familiar pale disk watches like a patient guardian. You've seen this scene thousands of times, but tonight, something feels different. Tonight, you begin to sense what ancient peoples knew instinctively, that luminous sphere isn't just hanging there, beautiful and distant. It's pulling at everything around you. The moon is Earth's secret conductor, orchestrating a symphony of forces that shape every moment of your existence. While you sleep, while you work, while you dream, it's there, tugging at the water in your body, influencing the rhythm of the tides outside your window, and maintaining the delicate balance that keeps our world habitable. Think of it like this. Imagine Earth as a spinning top, wobbling slightly as it spins. Without the moon's steady gravitational hand, that wobble would become a chaotic tumble. Our seasons would shift wildly, ice ages would come and go like weather patterns, and life as we know it simply couldn't exist. The moon is like a cosmic stabilizer, a gentle but firm hand keeping Earth's motion smooth and predictable. But here's where it gets truly fascinating. The moon isn't just any celestial companion, it's enormous. Compared to our planet, roughly the size of a quarter held next to a basketball. No other planet in our solar system has such a proportionally large moon. Mars has 2 tiny potato-shaped rocks. Jupiter has dozens of moons, but they're like pebbles scattered around a boulder. Our moon is different. It's a partner, not just a satellite. This partnership began in violence, 4.5 billion years ago, when our solar system was still a cosmic construction site. A Mars-sized object called Theia, named after the Greek goddess who gave birth to the moon goddess Selene, slammed into the young Earth with unimaginable force. The impact was so catastrophic it melted both worlds, flinging molten rock and metal into space. This debris cloud, glowing like a ring of fire around Earth, slowly gathered itself into the sphere we see today. The moon was literally born from Earth's flesh, which explains why lunar rocks brought back by Apollo astronauts have such similar composition to our planet's mantle. We are made of the same cosmic stuff, Earth and moon, like siblings separated at birth, but forever connected by invisible threads of gravity. From the very beginning, the moon has been shaping Earth's character. In those early days, when both worlds were still cooling from their violent birth, the moon orbited much closer, so close that it appeared 15 times larger in the sky than it does today. The tides it raised weren't gentle lappings at the shore, but massive walls of water that swept across continents twice a day. These ancient supertides may have been crucial for mixing the chemical ingredients that would eventually spark life. As eons passed, the moon began its slow retreat, moving away from Earth at about the same rate your fingernails grow, roughly 1.5 inches each year. This gradual separation has been like a cosmic dance, with Earth and moon locked in gravitational embrace, each partner influencing the other's rhythm. Earth's rotation has slowed from a frantic 6-hour day to our comfortable 24 hours, while the moon has settled into its current orbit, showing us always the same familiar face. Ancient civilizations looked up at this constant companion, and saw divinity. They weren't wrong to sense something profound at work. The Babylonians called it sin, the Greeks named it Selene, the Romans honored it as Luna. They built temples aligned with its phases, crafted calendars based on its cycles, and told stories of its power over human affairs. Modern science has revealed that their intuitions were remarkably accurate. The moon does indeed hold sway over earthly events in ways both subtle and profound. Today, as we stand on the threshold of returning humans to the lunar surface, we're beginning to understand just how deep this celestial relationship runs. The moon isn't just a pretty backdrop for romantic evenings or a convenient nightlight for late walks. It's the hidden architect of Earth's habitability, the silent guardian that has made complex life possible, and the cosmic timekeeper that has regulated the rhythm of existence for billions of years. Every time you feel the ocean breeze, watch the tide pools refill, or simply notice how the nights have their own special quality of light, you're experiencing the moon's influence. It's always there, always working, always maintaining the delicate conditions that allow you to exist. The moon doesn't just light up the darkness, it shapes the very nature of life itself. Moonlight, and the pull beneath our feet. Have you ever walked barefoot on wet sand as the tide recedes, feeling that strange, almost electric sensation where water meets earth? There's something primal about that moment, a connection to forces far greater than ourselves. What you're experiencing isn't just the pleasant squish of sand between your toes. You're feeling the moon's gravitational embrace, as real and tangible as a gentle hand pulling at every particle of your being. Right now, as you read these words, the moon is tugging at you, not metaphorically but literally, physically pulling every atom in your body with the same force that moves oceans. The water that makes up about 60% of your body weight responds to this celestial call, rising and falling in microscopic tides that ebb and flow within your very cells. Think of gravity not as a mysterious invisible force, but as the fabric of space itself being gently curved and stretched. Einstein showed us that massive objects like planets and moons don't really pull on things. They bend the cosmic fabric, creating valleys and slopes that everything else naturally follows. The moon has carved a vast, invisible valley in space-time around Earth, and we're all constantly rolling toward the bottom of that valley, held in perpetual free fall. But here's where it gets beautifully complex. As Earth spins on its axis every 24 hours, different parts of our planet move in and out of the moon's gravitational grip. When you're on the side of Earth facing the moon, you experience slightly stronger gravitational pull, about 0.03% stronger than average. When you're on the opposite side, 12 hours later you're in the moon's shadow, experiencing slightly weaker pull. These tiny variations might seem insignificant, but they're enough to move mountains literally. The solid rock beneath your feet rises and falls by about a foot, twice daily, due to lunar gravity. This phenomenon, called earth tide, happens so slowly and uniformly that you never notice it. It's like being inside a giant, imperceptibly breathing creature. Your body experiences these same tidal forces, but in ways that are endlessly debated among scientists. Some studies suggest that emergency room visits spike during full moons, that surgical bleeding increases, that psychiatric episodes become more frequent. Other research finds no connection at all. The truth likely lies somewhere in the middle. Our bodies are too small and too internally regulated to be dramatically affected by lunar gravity, but we may be sensitive to more subtle influences. Consider this fascinating fact. If you could somehow weigh yourself during a full moon versus a new moon, you would find a difference of about 57 thousandths of an ounce. That's roughly the weight of a large raindrop. Not much by human standards, but in the microscopic world of cellular biology, even tiny forces can have cascading effects. Ancient physicians believed the moon's phases affected bodily fluids, blood, lymph, and what they called humors. Medieval doctors timed surgeries by lunar calendars, and many refused to operate during certain moon phases. We might smile at such superstitions, but modern research has found intriguing correlations between lunar cycles and biological processes that we don't yet fully understand. Hospital staff often swear that full moon nights bring more chaos, more accidents, more births, more emergency calls. Scientists have spent decades trying to verify or debunk these claims, with mixed results. Some studies find weak but statistically significant correlations, others find none at all. The phenomenon might be psychological, rather than physical. Perhaps we're more likely to notice and remember unusual events when we expect them to occur, but the moon's gravitational influence extends far beyond potential effects on human behavior. Every drop of water on Earth, from the vast Pacific to the tiny moisture in your breath, responds to lunar pull. The atmosphere itself has tides, growing thicker and thinner in rhythm with the moon's position. Even the delicate balance of our planet's magnetic field shows subtle variations that correlate with lunar cycles. Mountain ranges experience tidal stress that can influence earthquake timing. GPS satellites must account for how lunar gravity slightly alters their orbital paths. Radio telescopes detect faint changes in Earth's shape that correspond to the moon's position. The pull beneath our feet is everywhere, constant and inescapable, a cosmic reminder that we live in a universe where everything is connected to everything else. Perhaps most remarkably, this gravitational dance between Earth and Moon is gradually slowing our planet's rotation. Eons ago, Earth spun much faster, giving us days only 6 hours long. The Moon's steady gravitational braking has stretched our days to their current comfortable length, creating the day-night cycle that has shaped the evolution of all terrestrial life. Every time you feel that peaceful rhythm of waves on a beach, you're witnessing the Moon's gravitational signature written in water. Every time you enjoy a 24-hour day with time for both activity and rest, you're benefiting from billions of years of lunar influence. The pull beneath our feet isn't just a curious scientific fact. It's the hidden foundation of the world we know. Tides, Earth's breathing, directed by the Moon. Stand at the edge of any ocean and watch the water for a while. Notice how it seems to breathe, slowly inhaling toward the shore, then exhaling back to deeper waters. This isn't mere wave action from distant storms. This is Earth's pulse, as regular and essential as your own heartbeat, and it's being conducted by our faithful celestial companion, the Moon. Twice each day, roughly every 12 hours and 25 minutes, the ocean rises and falls in a rhythm so fundamental that life itself has evolved to dance with it. Crabs scuttle out of their hiding places at precise moments, knowing exactly when the tide will expose fresh feeding grounds. Sea anemones close their petals in anticipation of dry periods. Fish move in great migrations timed to tidal flows that carry them to spawning grounds their ancestors have used for millions of years. The mechanism behind this cosmic choreography is elegantly simple, yet its effects are profound beyond imagination. The Moon's gravity pulls strongest on whatever part of Earth faces it directly. Water, being liquid and mobile, responds most dramatically to this pull, creating a bulge of elevated sea level on the moon-facing side of our planet. But here's the beautiful complexity. There's also a bulge on the opposite side of Earth in the Moon's shadow. Think of it like this. Imagine you're holding a water balloon and gently pulling on one side. The water inside doesn't just move toward your pull. It also creates a bulge on the far side as the balloon itself stretches. Earth works similarly, with the solid planet being pulled slightly away from the water on the far side, creating twin bulges of high tide, separated by regions of low tide. As Earth spins beneath these two tidal bulges, any given coastline experiences 2 high tides and 2 low tides each day. But the timing shifts by about 50 minutes daily because the Moon itself is orbiting Earth, moving eastward against the background of stars. This is why tide tables look like complex musical scores, with precise timings that shift gradually but predictably. The Sun also influences our tides, but with less than half the Moon's tidal strength despite being vastly more massive. Distance matters enormously in gravitational effects. The Sun is nearly 400 times farther away than the Moon, which weakens its tidal pull significantly. When Sun and Moon align during new and full moons, their gravitational forces combine to create spring tides, the highest highs and lowest lows. When they're at right angles during quarter moons, they partially cancel each other out, producing gentler neap tides. But tides are far more complex than simple high and low water. In the Bay of Fundy between Nova Scotia and New Brunswick, the ocean rises and falls by more than 50 feet twice daily, enough to cover a 4-story building. The incoming tide creates a visible wall of water called a tidal bore that surges up rivers like a slow-motion tsunami. Local residents have learned to park their cars well above the high tide mark and time their activities around these massive water movements. In other places, geography creates entirely different tidal personalities. The Mediterranean Sea, nearly enclosed by land, experiences tides of only a few inches, Some areas have just one high tide per day, instead of two, while others have 4 distinct tidal cycles. The shape of coastlines, the depth of ocean basins, and the contours of the seafloor all influence how tidal waves propagate and amplify. These aren't just academic curiosities. Tides have shaped human civilization in profound ways. The ancient Greeks and Romans built their ports and harbors around tidal schedules. Medieval monks in monastery kitchens timed their fish deliveries to the incoming tide that brought fresh chachas. Entire cities like Venice learned to dance with daily flood cycles, building elaborate systems of canals and bridges to work with rather than against the water's rhythm. Modern tide prediction requires some of the most sophisticated mathematics and computer modeling in all of science. Tidal forces interact with underwater mountain ranges, continental shelf contours, and the Coriolis effect from Earth's rotation to create patterns so complex that each harbor requires its own customized forecasting system. Yet, for all this complexity, the underlying rhythm remains beautifully simple: the moon's steady gravitational heartbeat. Tidal energy is becoming increasingly important as we seek renewable power sources. Underwater turbines in tidal streams can generate electricity with the predictability of clockwork, while tidal barrage systems trap high tide water behind dams and release it through generators as the tide falls. Unlike solar or wind power, tidal energy is completely predictable. We can calculate exactly how much power will be available at any given moment for the next 1,000 years. The ecological importance of tides cannot be overstated. Tidal zones are among the most biologically productive environments on Earth, where twice-daily changes in water level create unique habitats that support incredible diversity. Salt marshes, mangrove swamps, and rocky intertidal areas serve as nurseries for countless species, many of which time their reproductive cycles to tidal rhythms. Even more remarkably, tides may have been crucial for the origin of life itself. The regular cycling between wet and dry conditions in ancient tidal pools could have concentrated organic molecules and provided the energy gradients necessary for the first self-replicating chemicals. In a very real sense, we might all be children of the tides, products of the moon's patient cultivation of conditions suitable for life. Every time you feel the sand shift beneath your feet as a wave retreats, you're experiencing forces that connect you directly to the moon hanging in the sky above. Earth's breathing, directed by our celestial companion, continues its ancient rhythm, a rhythm that has shaped our world for billions of years and will continue long after we're gone. The moon's grip on time and rhythm. Close your eyes and listen to your heartbeat. Feel the steady rhythm, roughly 70 beats per minute, a tempo that has pulsed within you since before you were born. Now consider this remarkable fact: that rhythm, along with countless other cycles in your body, may be synchronized to patterns that trace back to the moon's ancient influence on life itself. Every living thing on Earth dances to internal clocks, biological rhythms that seem almost musical in their precision. Plants open their flowers at dawn and close them at dusk. Birds migrate thousands of miles with timing accurate to within days. Your own body temperature fluctuates in predictable waves throughout each 24-hour period. Your hormone levels rise and fall like tides, and your cells repair themselves according to schedules that have been maintained for millions of years. These circadian rhythms, from the Latin circa diem, meaning about a day, are so fundamental to life that they're found in everything from bacteria to blue whales. But here's what's truly fascinating. Many of these rhythms aren't exactly 24 hours long. Left to their own devices in constant laboratory conditions, most biological clocks run slightly longer than a solar day, often matching more closely the 24-hour and 50-minute lunar day. This isn't coincidence. It's a whisper from deep evolutionary time, when the moon's influence on Earth was far more dramatic than it is today. 4 billion years ago, when life was first learning to organize itself into complex patterns, the moon orbited much closer to Earth. Its gravitational effects were stronger, its tidal forces more pronounced, and its role in shaping the daily experience of early organisms was impossible to ignore. Think of the moon as evolution's first clock, providing a reliable timekeeper in an otherwise chaotic early world. Before sophisticated nervous systems, before complex brains, before any creature could consciously track time, the moon's cycles offered a predictable rhythm that life could use as a framework for growth, reproduction, and survival. Marine organisms still show the clearest connections to lunar timing. The grunion fish of Southern California beaches their bodies in silver waves during the highest spring tides, laying eggs in sand that will be undisturbed until the next extreme tide cycle hatches them. Coral reefs across the Pacific coordinate their spawning to lunar phases, releasing billions of eggs and sperm simultaneously in events so spectacular they can be seen from space. The pelodo worm of the South Pacific performs perhaps the most precise lunar dance of all. Exactly 7 days after the full moon in October and November, these segmented creatures rise from deep coral crevices to the ocean surface, where their reproductive segments detach and swarm in such numbers that the water looks like living soup. Pacific Islanders have harvested this protein-rich annual feast for centuries, marking their calendars by the moon's phases. But the moon's influence on biological timing extends far beyond the ocean. Many mammals show subtle but measurable changes in behavior and physiology that correlate with lunar cycles. Deer hunting guides will tell you that animal movement patterns shift with moon phases. Laboratory tastes of mice and rats show variations in activity levels, feeding behavior, and even susceptibility to seizures that follow lunar rhythms. Human circadian biology carries its own hints of ancient lunar connection. Women's menstrual cycles average 28 days, remarkably close to the moon's 29.5-day orbital period. Before artificial lighting, many cultures reported that women living together would synchronize their cycles not only with each other, but with specific moon phases. While modern lifestyle factors have largely disrupted these patterns, the underlying biological machinery remains, suggesting deep evolutionary roots. Sleep researchers have discovered that people tend to sleep less soundly and wake more frequently during full moons, even in windowless laboratory rooms, where they can't see the lunar phase. Brainwave patterns change subtly, REM sleep decreases, and the time it takes to fall asleep increases. The effect is small but statistically significant across thousands of test subjects, implying that our brains retain some sensitivity to the moon's position even when we're consciously unaware of it. The moon's role as timekeeper extends beyond biology into the realm of human culture and consciousness. Every major civilization developed lunar calendars before solar ones, finding it easier to track the moon's obvious phases than the sun's subtle seasonal changes. The Hebrew calendar, the Islamic calendar, and the traditional Chinese calendar all remain fundamentally lunar, dividing time into months that follow the moon's cycles rather than the sun's. Ancient agricultural societies planned their planting and harvesting by lunar phases, believing that the moon's gravitational pull affected not just ocean tides but the movement of sap in plants and moisture in soil. Modern scientific studies have found limited evidence for these effects, but the practices persist among organic farmers and gardeners who swear by lunar planting guides. Perhaps most intriguingly, the moon may have influenced the evolution of consciousness itself. Some researchers suggest that the regular alternation between bright moonlit nights and dark new moon periods helped shape the sleep-wake cycles that eventually led to the complex dream states characteristic of advanced nervous systems. The moon's light was bright enough to permit limited nighttime activity, but rhythmic enough to encourage the development of sophisticated internal clocks. The 24-hour day that feels so natural to us is actually a compromise between Earth's rotation and the moon's orbital period. Over billions of years, lunar gravity has slowed Earth's spin from a frantic 6-hour day to our current comfortable rhythm. This gradual lengthening may have been crucial for allowing complex life to evolve, providing enough time in each day-night cycle for the intricate biochemical processes that sustain large, complex organisms. Every time you feel sleepy at sunset or naturally wake at dawn, you're experiencing the legacy of the moon's ancient grip on time. The rhythms that pulse through your body, the cycles that govern your sleep and wakefulness, the biological clocks that coordinate your cellular repair and hormone production, all of these may trace their origins to that pale orb that has been keeping time for Earth's children since life began. Without the moon, there would be chaos. Imagine waking up one morning to find the moon simply gone, vanished from the sky, as if it had never existed. At first you might think the only difference would be darker nights and no more romantic moonlit walks, but within hours, the true magnitude of this cosmic catastrophe would begin to reveal itself. The world as we know it would unravel with terrifying speed, demonstrating just how crucial our celestial companion truly is. The first sign of disaster would come from the oceans. Without the moon's gravitational pull, the tides that have rhythmically risen and fallen for billions of years would suddenly cease. The twice-daily pulse that has shaped coastlines, guided marine ecosystems, and provided predictable cycles for countless species would simply stop. Ocean levels would redistribute themselves according to Earth's rotation and the sun's much weaker tidal influence, but the result would be chaos. Coastal ecosystems that depend on tidal zones would collapse almost immediately. Think of the millions of creatures, from tiny amphipods to massive elephant seals, whose entire life cycles are synchronized to tidal rhythms. Spawning cycles, feeding patterns and migration routes would all be thrown into disarray. Salt marshes and mangrove forests, among the most productive ecosystems on Earth, would either flood permanently or dry out completely as water levels restabilized. But the loss of tides would be just the beginning. Far more catastrophic would be the effect on Earth's rotation and axial tilt. The moon acts like a cosmic gyroscope, stabilizing our planet's wobble and maintaining the 23.5-degree tilt that gives us our seasons. Without this stabilizing influence, Earth would begin to tumble chaotically through space, its axis wandering like a spinning top, losing momentum. Computer simulations of a moonless Earth paint a terrifying picture. Our planet's tilt could vary anywhere from 0 degrees, giving us no seasons at all, to 90 degrees, where the poles would alternately point directly at the sun. Imagine winters so severe that the entire planet freezes, followed by summers so intense that the ice caps melt completely. These extreme climate swings could happen over periods ranging from thousands to millions of years, making long-term adaptation nearly impossible. The biological consequences would be devastating. Most complex life forms have evolved intricate adaptations to seasonal changes. Hibernation patterns, migration routes, breeding cycles, and plant growth rhythms all depend on the predictable progression of seasons that the moon's stabilizing influence provides. Without seasonal stability, food webs would collapse as predators and prey fell out of synchronization, and as plants fail to coordinate their reproductive cycles with favorable conditions. Earth's day-night cycle would also change dramatically without the moon. Currently, our planet rotates once every 24 hours, but this comfortable rhythm is the result of billions of years of lunar braking. Without the moon's gravitational drag, Earth would gradually speed up its rotation, eventually spinning so fast that days might last only 6 to 8 hours. Such rapid rotation would create fierce winds and extreme weather patterns, unlike anything in our current climate. The psychological and cultural impact on humanity would be profound. The moon has been our constant companion throughout human evolution, influencing our myths, religions, calendars, and sense of time itself. Suddenly losing this celestial anchor would represent a trauma beyond anything our species has ever experienced. The regular cycle of lunar phases that has helped humans track time for millennia would be gone, forcing us to completely restructure our understanding of temporal rhythms. Navigation would become far more difficult. For thousands of years, sailors and travelers have used the moon's position and phase to determine direction and time. The loss of this celestial reference point would be particularly devastating for migrating animals that use lunar cues to navigate across vast distances. Sea turtles, which already struggle with light pollution disrupting their navigation, would lose one of their most reliable guides. The Earth's magnetic field might also be affected in ways we don't fully understand. Some scientists believe the moon's gravitational influence helps maintain the circulation patterns in Earth's molten core that generate our magnetic field. Without this protective barrier, our planet would be more exposed to harmful solar radiation and cosmic rays, potentially making the surface uninhabitable for many forms of life. Even more subtly, the loss of the moon would affect the very shape of our planet. Earth is not a perfect sphere, it's slightly flattened at the poles and bulged at the equator, partly due to rotation and partly due to the moon's gravitational influence. Without the moon, our planet would slowly reshape itself, potentially triggering massive earthquakes and volcanic activity as the crust adjusted to new stress patterns. The climate effects would cascade through every system on Earth. Ocean currents, which depend partly on tidal mixing to maintain their global circulation patterns, would reorganize themselves unpredictably. The Gulf Stream that keeps Europe warm, the currents that bring nutrients to productive fishing grounds, and the circulation patterns that distribute heat from equator to poles, would all change in ways that could make large regions uninhabitable. Perhaps most remarkably, we're beginning to understand that the moon may have been essential for the origin of life itself. The early Earth's massive tides, created by a much closer moon, may have provided the energy and chemical mixing necessary for the first organic molecules to organize themselves into living systems. The regular cycling between wet and dry conditions in tidal pools could have been the crucible where life learned to replicate and evolve. Without the moon, Earth might have remained a sterile, chaotic world too unstable for the delicate processes that eventually led to the incredible diversity of life we see today. Every time you look up at the throne, you're seeing not just a beautiful celestial object, but the guardian that has made your existence possible. In a universe of countless worlds, we are extraordinarily fortunate to have found ourselves on one with such a perfect cosmic companion. How the moon stabilized Earth's wobble. Picture a figure skater spinning gracefully on ice, arms outstretched, maintaining perfect balance as they whirl faster and faster. Now imagine what would happen if they suddenly lost that balance. The elegant spin would become a chaotic tumble, arms and legs flailing as they crash to the ice. This is essentially what Earth would be like without the moon's steadying influence. A world spinning wildly out of control, tumbling through space with no stable orientation. Every spinning object in the universe has a tendency to wobble, and Earth is no exception. Our planet is not a perfect sphere, it's slightly flattened at the poles and bulged at the equator, with an uneven distribution of mass from mountains, ocean basins, and continental plates. Left to its own devices, Earth would wobble like an unbalanced washing machine, its rotational axis wandering unpredictably across the sky. The moon acts as Earth's cosmic stabilizer, a gravitational anchor that keeps our planet's wobble within narrow, manageable limits. Think of it like a tightrope walker's balance pole. The moon's steady gravitational pull helps maintain Earth's orientation in space, preventing the catastrophic tumbling that would make complex life impossible. This stabilization happens through a beautiful interplay of gravitational forces and rotational physics. Earth's equatorial bulge, caused by centrifugal force from our planet's rotation, creates a gravitational handle that the moon can grab onto. When Earth tries to tip too far in any direction, the moon's gravity tugs on this bulge, gently pulling our planet back toward a stable orientation. The effect is subtle, but crucial. Without the moon, computer models show that Earth's axial tilt, currently a stable 23.5 degrees, could vary anywhere from 0 to 90 degrees, over periods ranging from millions to tens of millions of years. Mars, which has 2 tiny moons with negligible stabilizing effect, shows exactly this kind of chaotic wobbling. Martian seasons are wildly unpredictable over geological time, with ice ages and warming periods occurring seemingly at random. To understand why this matters so much, consider what our seasons actually are. Earth's tilted axis means that for half of each orbit around the Sun, the northern hemisphere leans toward our star while the southern hemisphere leans away, creating summer in the north and winter in the south. 6 months later, the situation reverses. This predictable seasonal cycle has been the foundation for the evolution of virtually all complex life on Earth. Plants have evolved intricate timing mechanisms that allow them to sprout in spring, grow through summer, reproduce in fall, and survive winter dormancy. Animals migrate along routes and schedules that take advantage of seasonal food availability. Predator and prey populations fluctuate in cycles that depend on predictable seasonal changes. Remove this stability, and the entire web of life begins to unravel. Imagine if winter could last for decades, followed by centuries of scorching summer, then sudden shifts to periods with no seasons at all. No species could adapt to such chaotic climate swings. Agriculture would be impossible. Ecosystems would collapse as organisms lost the seasonal cues they've depended on for millions of years. The moon's stabilizing influence extends beyond just preventing extreme tilts. It also dampens smaller variations in Earth's rotational behavior. Our planet experiences tiny wobbles called Chandler wobbles, where the rotational axis traces small circles over periods of about 14 months. The moon's gravity helps keep these wobbles small and regular. Without this lunar damping, Earth's rotation could become much more erratic. Even more remarkably, the moon has been fine-tuning Earth's stability for billions of years. In the early days of the Earth-Moon system, when our satellite orbited much closer, its stabilizing effect was even stronger. As the moon gradually moved away due to tidal friction, it maintained just the right amount of stabilizing influence to keep Earth habitable, while allowing for gradual climate changes that drove evolution forward. This delicate balance represents one of the most remarkable coincidences in our solar system. The moon is just the right size, at just the right distance, with just the right orbital characteristics to provide optimal stability for a living world. Too small, and it couldn't prevent chaotic tumbling. Too large, and it might lock Earth into a rigid orientation that prevented the gradual climate changes necessary for evolutionary adaptation. Too close, and its tidal forces would be devastating. Too far, and its stabilizing influence would be negligible. Some scientists argue that this Goldilocks relationship between Earth and Moon is so improbable that it suggests our solar system is truly special, perhaps even suggesting that Earth-like planets with large stabilizing moons are exceedingly rare in the universe. The giant impact hypothesis, which explains the Moon's formation through a collision between early Earth and a Mars-sized object, describes an event so unlikely that it might happen only once in billions of star systems. The cultural implications of lunar stabilization are profound. Human civilization has developed under the assumption of predictable seasons, stable climate patterns, and regular day-night cycles. Our agriculture, our architecture, our social structures, and even our psychological well-being are all adapted to the stable rotational environment that the Moon provides. We are creatures of seasonal rhythm, shaped by millions of years of evolution under lunar-stabilized conditions. Archaeological evidence suggests that early humans were acutely aware of seasonal cycles, creating elaborate stone calendars and astronomical observatories to track the sun's movement through the year. These monuments represent humanity's first attempts to understand the cosmic forces that govern our world, forces that ultimately trace back to the Moon's stabilizing influence on Earth's rotation. Modern climate science has revealed just how sensitive Earth's climate system is to small changes in orbital parameters. The ice ages that have shaped our planet's recent history are triggered partly by tiny variations in Earth's orbital eccentricity, tilt, and wobble, variations that the Moon helps keep within manageable bounds. Without lunar stabilization, these climate oscillations could be far more extreme and unpredictable. Every time you enjoy the predictable progression of seasons, the first warm day of spring, the peak heat of summer, the colorful leaves of autumn, the quiet beauty of winter snow, you're experiencing the gift of the Moon's stabilizing presence. That gentle wobble that the Moon prevents would be the end of the world as we know it, transforming our stable, life-friendly planet into a chaotic, uninhabitable tumbler, spinning wildly through the void. Lunar light and the birth of calendars. Stand outside on a clear night during a full moon, when the landscape is bathed in silvery light, bright enough to read by, and you're witnessing humanity's first clock. Long before mechanical timepieces, before sundials, before any sophisticated understanding of astronomy, our ancestors looked up at the Moon's changing face and saw the passage of time itself written across the sky. The Moon's phases unfold with such perfect regularity that they seem almost designed for timekeeping. Every 29.5 days, the lunar cycle completes its journey. From invisible new moon through waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, waning crescent, and back to new moon again. This celestial rhythm was so obvious and so reliable that virtually every human culture built their first calendars around it. Think about how revolutionary this must have been for early human societies. In a world where most natural events seemed chaotic and unpredictable, when would the rains come? When would the herds migrate? When would winter end? The Moon offered something precious: certainty. Night after night, generation after generation, the lunar phases repeated their ancient dance with clockwork precision. The word month itself comes from moon, revealing how deeply lunar timekeeping is embedded in our language and consciousness. The concept of weeks, 7-day periods that divide the lunar month into 4, approximately equal parts, likely originated from the easily observable phases of the Moon. First quarter, full moon, last quarter, and new moon each occur roughly 7 days apart, giving our ancestors a natural subdivision of time that felt both practical and sacred. Cave paintings from over 30,000 years ago show sequences of marks that archaeologists believe represent lunar counts. These ancient calendar keepers weren't just tracking time, they were beginning to understand the relationship between celestial cycles and earthly events. They noticed that animal migrations, plant flowering, and seasonal changes often coincided with particular moon phases, allowing them to predict and prepare for important events. The Babylonians, master astronomers of the ancient world, created the first sophisticated lunar calendar around 2000 BCE. They divided the year into 12 lunar months, each beginning with the first sighting of the crescent moon after the new moon phase. This system was so effective that it spread throughout the Middle East and formed the foundation for Hebrew, Islamic, and many other calendar systems still in use today. But here's where lunar calendars reveal their beautiful complexity. 12 lunar months add up to only 34 days, falling 11 days short of the 65-day solar year that governs seasons. Ancient calendar keepers faced a fundamental challenge. Should they follow the moon's reliable phases or the sun's seasonal rhythm? Different cultures chose different solutions, creating a rich tapestry of timekeeping systems that reflect humanity's relationship with both celestial bodies. The Islamic calendar remains purely lunar, allowing religious festivals to drift through the seasons over a 33-year cycle. Ramadan, the month of fasting, sometimes falls in the heat of summer, sometimes in the cool of winter, connecting Muslim communities to the moon's rhythm rather than seasonal changes. This creates a unique spiritual relationship with time, where sacred periods are defined by celestial mechanics rather than earthly weather. The Hebrew calendar ingeniously combines lunar and solar elements, adding an extra month 7 times every 19 years to keep holidays aligned with appropriate seasons. Passover always falls in spring, Rosh Hashanah in autumn, maintaining the agricultural connections that were vital to ancient Jewish life while preserving the lunar foundation of the timekeeping system. Chinese traditional calendar represents perhaps the most sophisticated attempt to harmonize lunar and solar cycles. Each month begins with a new moon, but the year is adjusted to match seasonal patterns through complex intercalation rules. The result is a calendar that serves both practical agricultural needs and spiritual connections to celestial rhythms, with festivals like Chinese New Year falling on dates that seem to shift randomly in our Gregorian system, but follow precise lunar-solar mathematics. The moon's role in calendar development wasn't just practical, it was deeply spiritual. Many cultures saw the lunar cycle as a metaphor for life, death, and rebirth. The moon's monthly death during the new moon phase, followed by its gradual resurrection as a crescent, then its full glory and finally its waning toward death again, seemed to mirror the cycles of human life and the natural world. Ancient Egyptian calendars tracked both lunar months and the heliacal rising of Sirius, the bright star whose appearance before dawn announced the annual Nile flood. But they also maintained lunar festivals and ceremonies, recognizing that different aspects of life required different temporal frameworks. Religious ceremonies followed the moon, agricultural activities followed the sun and stars, creating multiple overlapping time systems that reflected the complexity of their civilization. The Romans initially used a lunar calendar so chaotic that their priests regularly added or subtracted days to keep festivals in appropriate seasons. Julius Caesar finally abandoned this system in favor of a solar calendar, but he couldn't eliminate the moon's influence entirely. Easter, Christianity's most important holiday, is still calculated based on lunar phases, falling on the first Sunday after the first full moon following the spring equinox, a formula that connects Christian celebration to both solar seasons and lunar cycles. Medieval monks maintained elaborate lunar calendars to calculate Easter dates decades in advance, creating tables of astronomical calculations that represented some of the most sophisticated mathematics of their time. Monasteries became centers of astronomical learning, partly because accurate lunar calculations were essential for religious observance. The moon's influence on timekeeping extended beyond formal calendars into the rhythms of daily life. Before artificial lighting, the lunar cycle determined when people could travel safely at night, when outdoor work could continue after sunset, and when communities could gather for evening activities. Full moon nights were times of celebration and extended activity, while new moon periods encouraged rest and indoor work. Agricultural societies developed elaborate systems of lunar planting guides, believing that the moon's gravitational influence affected not just ocean tides but the movement of sap in plants and moisture in soil. While modern science finds limited evidence for these effects, the practices persist among organic farmers and gardeners who swear by lunar planting calendars. Whether the effects are real or not, these traditions represent humanity's deepest intuitions about our connection to celestial cycles. The development of accurate mechanical clocks and watches might seem to have made lunar timekeeping obsolete, but the moon's role in organizing human time remains surprisingly strong. Financial markets still show subtle patterns that correlate with lunar phases. Hospital emergency rooms report changes in patient flow that follow monthly cycles. Even in our electrically illuminated world, many people report sleep disturbances and mood changes that seem connected to the moon's phases. Perhaps most remarkably, recent research suggests that human circadian rhythms, our internal biological clocks, may still be subtly synchronized to lunar cycles. In laboratory studies where people are isolated from all time cues, some individuals show activity patterns that follow 24-hour and 50-minute cycles, matching the lunar day rather than the solar day. This hints at deep evolutionary connections between human biology and the moon's rhythm that persist even in our modern, artificially lit environment. Every time you glance at a calendar, check the date on your phone, or plan activities for the weekend, you're using concepts that trace their origins to ancient people studying the moon's phases. The very idea that time can be divided into regular, predictable units, months, weeks, days, emerged from humanity's first sustained observation of the night sky. The moon didn't just light our ancestors' way through the darkness, it taught them that time itself could be understood, predicted, and organized. The secret link between moon phases and life cycles. Walk through any tidal pool during a full moon night, and you'll witness one of nature's most ancient spectacles. Countless creatures responding to lunar rhythms with behaviors so precisely timed they seem choreographed by an invisible conductor. Hermit crabs emerge from crevices they've hidden in for weeks. Sea urchins release their reproductive cells in synchronized clouds, and tiny fish fry appear in numbers that transform the water into living silver. This isn't coincidence or folklore. It's biology responding to the moon's gravitational pulse in ways that have been refined over hundreds of millions of years. Life on Earth didn't just adapt to the moon's presence. It learned to dance with it, weaving lunar rhythms so deeply into biological processes that even creatures living far from the ocean still carry the moon's signature in their genes. The connection begins with the most fundamental process of all, reproduction. Across the natural world, countless species time their mating and spawning to lunar phases with precision that rivals any Swiss timepiece. The logic is elegant. By synchronizing reproduction to predictable celestial cycles, entire populations can coordinate their activities, overwhelming predators with sheer numbers and ensuring that at least some offspring survive to carry on the species. Consider the remarkable case of the Pololo worm in the South Pacific. These segmented marine creatures spend most of their lives hidden deep within coral reefs, but on precisely 2 nights each year, exactly 7 days after the October and November full moons, something extraordinary happens. The worm's rear segments, swollen with eggs and sperm, detach from their bodies and rise to the ocean surface in such massive numbers that the water looks like thick soup. Pacific Islanders have harvested this annual feast for over 1,000 years, marking their calendars by the moon's phases and knowing exactly when the sea will offer its gift of protein-rich reproductive segments. The timing is so precise that modern marine biologists still struggle to understand exactly how the worms coordinate their internal clocks to the lunar cycle. Coral reefs throughout the world's oceans stage similar spectacular events, with entire reef systems releasing billions of eggs and sperm simultaneously during specific lunar phases. The Great Barrier Reef's annual spawning, typically occurring 4 to 6 nights after the full moon in November, creates underwater blizzards of reproductive cells, so dense they can be seen by satellites. This mass spawning represents one of the largest synchronized reproductive events on Earth, and it's conducted entirely by the moon's rhythm. The grunion fish of Southern California beaches demonstrate perhaps the most precisely timed lunar reproduction of any vertebrate. These silvery fish ride the highest spring tides onto sandy beaches, where females bury themselves tail first in the sand to lay their eggs while males wrap around them to release sperm. The timing is so exact that the next extremely high tide, approximately 2 weeks later, arrives just as the eggs are ready to hatch, washing the newly emerged fry back to sea. But lunar influences on life cycles extend far beyond marine environments. Many terrestrial insects, birds, and mammals show reproductive behaviors that correlate with moon phases, even when they have no direct exposure to tidal forces. Some bird species time their migrations to lunar cycles, possibly using the moon's light for navigation or taking advantage of reduced predation during darker new moon periods. Fruit bats in tropical rainforest coordinate their feeding flights with lunar phases, avoiding the brightest full moon nights when they're most visible to predators. Many small mammals alter their foraging behavior based on lunar illumination, creating cascading effects through entire forest ecosystems. When mice and rats reduce their nighttime activity during full moons, owl populations must adjust their hunting strategies, which in turn affects the survival rates of other small prey species. The relationship between lunar cycles and human reproduction has been debated for centuries, with some of the most intriguing evidence coming from historical records and traditional knowledge. Before artificial lighting, many cultures reported that women's menstrual cycles synchronized not only with each other but with specific moon phases. The average length of human menstrual cycles, 28 days, is remarkably close to the moon's 29.5-day orbital period. Modern statistical analyses of birth records show weak but persistent correlations between lunar phases and human birth rates, with some studies finding slight increases in births during full moons and others finding the opposite pattern. The effects are small and inconsistent, suggesting that if lunar influences on human reproduction exist, they're largely overwhelmed by the complex factors of modern life. More compelling evidence comes from studies of other aspects of human biology that might retain lunar sensitivity. Sleep researchers have documented changes in brain wave patterns, REM sleep duration, and sleep quality that correlate with lunar phases. The effects persist even in windowless laboratory environments, suggesting that our nervous systems might retain some sensitivity to gravitational or electromagnetic changes associated with the moon's position. Hospital emergency rooms have long reported unofficial observations of increased patient flow during full moons, though scientific studies produce mixed results. Some analyses find statistically significant correlations between lunar phases and psychiatric emergencies, trauma cases, or seizure rates, while others find no connection at all. The phenomenon might be partly psychological. Healthcare workers expecting busier full moon nights might be more likely to notice and remember unusual events when they occur. The moon's influence on plant biology represents one of the most enduring but scientifically controversial areas of lunar biological research. Traditional agricultural wisdom holds that plants grow differently depending on moon phases, with root crops planted during waning moons and leafy crops during waxing moons. Organic farmers and biodynamic agriculturists maintain detailed lunar planting calendars, timing their seeding, transplanting, and harvesting to specific moon phases. Scientific studies of lunar effects on plant growth produce inconsistent results, with some experiments showing small but measurable differences in germination rates, growth speed, or yield based on planting timing relative to moon phases. The proposed mechanisms range from gravitational effects on water movement in plant tissues to electromagnetic influences on cellular processes, but none have been definitively proven. What's clear is that many plants do show circadian rhythms that are slightly longer than 24 hours, sometimes matching the 24-hour and 50-minute lunar day. These circa-lunar rhythms might represent evolutionary remnants from the distant past, when the moon's influence on Earth was stronger and more obvious to terrestrial organisms. Perhaps most fascinating is the growing evidence that lunar rhythms might be embedded in the basic architecture of biological clocks. The molecular machinery that controls circadian rhythms in everything from bacteria to humans shows striking similarities across all life forms, suggesting that these timing systems evolved early in Earth's history when the moon's influence was more pronounced. Some researchers propose that life's fundamental biological clocks originally evolved to track lunar rather than solar cycles, later adapting to the 24-hour day-night cycle while retaining subtle sensitivities to the moon's rhythm. This would explain why so many organisms show biological cycles that are slightly longer than 24 hours, and why lunar correlations persist across such diverse life forms. Every time you witness the synchronized emergence of mayflies on a summer evening, notice how your garden seems more active during certain times of the month, or feel your own energy levels fluctuating in subtle monthly rhythms, you might be experiencing echoes of the moon's ancient influence on life. The secret link between lunar phases and biological cycles represents one of the deepest connections between Earth's living systems and the cosmos, a reminder that we are all children of both Earth and sky, shaped by forces that connect us to the vast celestial dance surrounding our world. A hidden influence on animal migration and reproduction. Imagine standing on a beach in Costa Rica at night, watching thousands of sea turtles emerge from the ocean in a scene that seems almost prehistoric. These ancient mariners have navigated thousands of miles across open ocean to return to the exact beach where they were born decades ago. How do they find their way with such precision? The answer lies partly in the sky above. They're following the moon. The moon serves as nature's lighthouse, guiding countless species across vast distances in migrations that span continents and oceans. For millions of years, animals have used lunar cues for navigation, timing, and coordination of their most critical life activities. This celestial partnership between Earth's creatures and their cosmic companion represents one of the most remarkable examples of how life adapts to use every available environmental cue for survival. Sea turtles are perhaps the most famous lunar navigators. Newly hatched turtles use the moon's reflection on water to distinguish ocean from land, instinctively crawling toward the brightest horizon where waves reflect moonlight. Adult females time their nesting to coincide with the highest tides of the lunar cycle, ensuring their eggs are buried above the normal high tide line where they'll remain safe during the 2-month incubation period. But the moon's influence on turtle reproduction goes even deeper. Many sea turtle species coordinate their mass nesting events called arribadas with specific lunar phases. On beaches in Costa Rica and Mexico, thousands of olive ridley turtles emerge simultaneously during the days following a new moon, creating one of nature's most spectacular reproductive gatherings. The synchronized timing overwhelms predators and increases the chances that at least some nests will survive. This strategy, using lunar cycles to coordinate mass reproductive events, appears throughout the animal kingdom. Horseshoe crabs along the Atlantic coast time their spawning to the highest spring tides, which occur during new and full moons. Millions of these living fossils emerge from deep water to mate and lay eggs in the intertidal zone, creating a feast for migrating shorebirds that has been repeated for over 400 million years. The timing is so precise that shorebird migration routes across North America are synchronized to these lunar-timed horseshoe crab spawning events. Red knots, small sandpipers that fly from the Arctic to South America, time their northbound journey to arrive at Delaware Bay beaches, exactly when horseshoe crab eggs are most abundant. The birds depend on this high-energy food source to fuel the final leg of their journey to Arctic breeding grounds. Nocturnal migrations often follow lunar schedules for both navigational and safety reasons. Many bird species prefer to migrate during darker moon phases when they're less visible to predators, while others take advantage of moonlit nights when visibility is better for navigation. Researchers tracking migrating songbirds with radar have documented clear correlations between lunar phases and the intensity of nighttime migration. Monarch butterflies, famous for their multi-generational migration from Canada to Mexico, use a complex combination of sun compass navigation and magnetic field detection, but recent research suggests they may also use lunar cues, particularly during the portion of their journey when they fly at night. The moon's position provides a stable reference point that complements their other navigational systems. Marine animals show some of the most dramatic examples of lunar synchronized reproduction. In the Caribbean, parrotfish gather in massive spawning aggregations that occur precisely at sunset during specific lunar phases. These fish spend most of their lives in small groups on coral reefs, but during their reproductive season, thousands converge at traditional spawning sites, following an internal calendar synchronized to the moon's rhythm. Reef fish reproduction is often a community event, with multiple species timing their spawning to coincide with the same lunar phases. This creates underwater festivals of reproduction, where the water becomes cloudy with eggs and sperm from dozens of fish species simultaneously. The synchronized timing ensures that predators cannot consume all the reproductive output, while also providing the chaos and confusion necessary for successful fertilization. The lunar timing of these mass spawning events has profound implications for entire ocean ecosystems. Juvenile fish recruitment, the number of young fish that survive to adulthood, often depends on being born during optimal conditions. Lunar-timed spawning helps ensure that fish larvae are released when tidal patterns will carry them to appropriate nursery areas, and when plankton blooms provide adequate food. Even terrestrial mammals show subtle but measurable responses to lunar cycles in their reproductive behavior. Deer hunting guides have long claimed that animal movement patterns change with moon phases, and scientific studies have confirmed that many mammals alter their activity levels, feeding patterns, and mating behaviors in correlation with lunar cycles. Wolves, coyotes, and other pack hunters may coordinate their activities with lunar phases, using moonlight to extend hunting periods, or avoiding bright nights when prey animals are more alert. Some studies suggest that wolf howling increases during full moons, possibly because the additional light allows for more effective pack coordination during hunts. The moon's influence on migration and reproduction extends to some surprising species. Certain spider species balloon releasing silk threads to catch wind currents for long-distance dispersal. More frequently during specific lunar phases, some bat species alter their foraging patterns based on lunar illumination, with insectivorous bats avoiding bright nights when they're more vulnerable to owl predation. Perhaps most remarkably, Research is revealing that many animals possess internal clocks that track lunar cycles independently of environmental light cues. Laboratory studies of marine animals kept in constant conditions show that their biological rhythms continue to follow lunar patterns even when they can't see the moon or experience tidal changes. This suggests that lunar timing mechanisms are genetically encoded and represent fundamental adaptations to life on a planet with a large moon. The disruption of lunar cues by artificial lighting represents an emerging conservation concern. Sea turtle hatchlings become disoriented by beachfront lighting, crawling toward hotel lights instead as following the moon's reflection on the ocean. Migrating birds are attracted to brightly lit buildings and communication towers, leading to massive mortality events during peak migration periods. Light pollution doesn't just interfere with animals that use the moon for navigation. It also disrupts the subtle light cycles that many species use to synchronize their biological clocks. Even small amounts of artificial light can shift the timing of reproductive cycles, migration behavior, and feeding patterns in ways that can have cascading effects through entire ecosystems. Climate change adds another layer of complexity to lunar synchronized animal behaviors. As ocean temperatures rise and weather patterns shift, the environmental conditions that traditionally coincide with specific lunar phases are changing. Animals that rely on the coordination between lunar cycles, tidal patterns, temperature and food availability may find their ancient timing systems out of sync with current conditions. Every time you witness the remarkable precision of animal migrations, the return of swallows to the same barn each spring, the arrival of whales at traditional feeding grounds, the synchronized emergence of insects, you're seeing the result of countless generations of evolutionary fine-tuning to environmental cycles that include the moon's rhythm. These creatures carry lunar calendars in their genes, internal chronometers that connect them to the cosmic dance between Earth and its celestial companion. The hidden influence of lunar cycles on animal migration and reproduction reveals a truth that extends beyond biology. We live in a universe where everything is connected to everything else, where the position of celestial bodies influences the most intimate behaviors of Earth's creatures, and where the moon serves not just as a distant light in the sky, but as an active participant in the ongoing story of life on our planet. The moon's whisper in Earth's weather. Step outside during a thunderstorm and feel the electric charge in the air, the way the atmosphere seems to pulse with energy. Now consider this startling possibility: that cosmic whisper you sense might actually be the moon's gravitational influence, rippling through Earth's atmosphere, subtly affecting weather patterns in ways that meteorologists are only beginning to understand. The moon doesn't just pull on our oceans, it tugs at every particle of air in Earth's atmosphere, creating atmospheric tides that rise and fall with the same rhythm as ocean tides. These aerial tides are invisible to our eyes but detectable by sensitive instruments, causing our atmosphere to literally breathe in response to lunar gravity. The effect is small. Atmospheric pressure changes by only about 50 millionths of an atmosphere. But in the delicate balance of weather systems, even tiny influences can cascade into significant effects. Think of Earth's atmosphere as a vast, three-dimensional ocean of air, constantly in motion, with pressure waves, density variations, and circulation patterns that respond to gravitational forces just like water does. When the moon passes overhead, it creates a subtle bulge in the atmosphere directly below it, while the air on the opposite side of Earth experiences a corresponding depression. These atmospheric tides move around the planet twice daily, creating pressure oscillations that interact with other weather patterns. The discovery of atmospheric tides surprised early meteorologists, who expected the sun's heating to dominate all atmospheric behavior, but careful measurements revealed that the atmosphere also responds to purely gravitational forces, independent of heating effects. This means the moon influences weather through two distinct mechanisms: thermal tides caused by solar heating, and gravitational tides caused by the moon's pull. Gravitational atmospheric tides are strongest at the equator, where Earth's atmosphere is thickest and most responsive to tidal forces. In tropical regions, these lunar influences may contribute to the timing of daily thunderstorm cycles. Some research suggests that atmospheric instability, the conditions that lead to storm formation, shows subtle correlations with lunar phases, particularly in areas where other factors create near-threshold conditions for precipitation. The moon's influence on weather becomes more intriguing when we consider how it interacts with Earth's jet streams, the high-altitude rivers of fast-moving air that steer weather systems around the globe. Some meteorologists have found weak but statistically significant correlations between lunar phases and changes in jet stream behavior, particularly the tendency for these atmospheric rivers to become more wavy or unstable during certain moon phases. These jet stream variations could potentially influence everything from the path of winter storms to the persistence of heat waves and cold snaps. A slight nudge to jet stream patterns at just the right time might determine whether a storm system brings rain to drought-stricken regions or passes harmlessly out to sea. The effects would be subtle and difficult to predict, but over time they could contribute to long-term climate patterns. Rainfall patterns show some of the most intriguing potential lunar connections. Studies from around the world have found weak but persistent correlations between lunar phases and precipitation amounts, though the results vary significantly by geographic location and season. Some regions appear to receive slightly more rainfall during certain moon phases, while others show the opposite pattern. The proposed mechanism involves the moon's influence on atmospheric circulation patterns and the formation of clouds. Tiny changes in atmospheric pressure and air movement, caused by lunar gravity, might affect how water vapor condenses into droplets, and how those droplets organize into cloud systems. In regions where atmospheric conditions are right at the threshold for precipitation, the moon's subtle influence might tip the balance between a clear day and a rainy one. Lighting activity has also been linked to lunar cycles in some studies, with researchers finding correlations between lunar phases and the frequency or intensity of thunderstorms in certain regions. The mechanism might involve lunar influences on atmospheric electivity, or it could be related to changes in atmospheric stability that affect storm formation. The correlations are weak and inconsistent, suggesting that lunar effects on lightning are probably overwhelmed by more dominant factors like temperature and humidity. Temperature patterns present another area where lunar influences might play a subtle role. Some research suggests that daily temperature ranges, the difference between daytime highs and nighttime lows, vary slightly with lunar phases. The proposed explanation involves lunar effects on atmospheric circulation that influence how heat is distributed vertically through the atmosphere, affecting both surface warming during the day and radiative cooling at night. Wind patterns, too, might carry the moon's signature. The gravitational atmospheric tides create very weak but measurable changes in wind speed and direction that follow lunar cycles. These effects are strongest in the upper atmosphere, where the air is thinner and more responsive to gravitational influence. At ground level, lunar effects on wind are generally overwhelmed by topographic and thermal influences, but they might still contribute to the complex equation that determines local weather patterns. The moon's influence on weather becomes more complex when we consider its interaction with ocean currents and sea surface temperatures. The same tidal forces that create ocean tides also influence deep water circulation patterns, which in turn affect how heat is distributed through the world's oceans. Changes in sea surface temperature, even small ones, can have profound effects on weather patterns, particularly in the formation and intensity of tropical storms and hurricanes. Some researchers have investigated whether hurricane formation shows lunar correlations, given that these storms depend critically on sea surface temperatures and atmospheric conditions that might be influenced by tidal forces. The results are mixed, with some studies finding weak correlations between hurricane activity and lunar phases, while others find no connection. The complexity of hurricane formation involves so many variables that isolating lunar effects is extremely challenging. Seasonal weather patterns might also carry subtle lunar influences. The moon's orbit is slightly tilted relative to Earth's equator, causing the strength of tidal forces to vary with the seasons. These variations could potentially contribute to long-term climate oscillations, though such effects would be nearly impossible to separate from other climate drivers like solar cycles, volcanic activity, and human influences. Perhaps most intriguingly, some researchers have suggested that the moon's influence on weather might help explain certain puzzling aspects of climate variability. The fact that weather patterns often show periodicities that don't match solar cycles exactly has led some scientists to investigate whether lunar cycles might provide missing pieces of the climate puzzle. Modern weather prediction models don't explicitly include lunar influences, partly because the effects are small compared to other factors, and partly because the mechanisms aren't well enough understood to incorporate accurately. However, as our understanding of atmospheric physics becomes more sophisticated and our measurements more precise, it's possible that lunar effects might eventually be included in weather forecasting systems. The practical implications of lunar weather influences remain unclear. If the effects are real but small, they might not significantly improve weather prediction accuracy. However, in specialized situations such as predicting extreme weather events or understanding long-term climate trends, even small lunar influences might prove important. Every time you experience an unexpected weather change, notice how storms seem to follow mysterious patterns, or feel that electric anticipation in the air before a thunderstorm. You might be sensing the subtle dance between Earth's atmosphere and its celestial companion. The moon's whisper in Earth's weather represents one of the most challenging frontiers in atmospheric science, a reminder that our planet exists within a complex gravitational environment, where even distant objects can influence the air we breathe and the weather we experience. Earthquakes and moonquakes. A gravitational dance. Feel the solid ground beneath your feet. It seems so stable, so permanent, like the one thing in our chaotic world that you can always count on. But Earth's crust is actually in constant motion, flexing and breathing in response to gravitational forces that stretch far beyond our planet. The moon, hanging silently in the sky above, is gently kneading the rock beneath your feet, like an invisible pair of hands working clay. Every day, the solid Earth rises and falls by about a foot in response to lunar gravity. This phenomenon, called Earth tide, happens so gradually and uniformly that you never feel it, but sensitive instruments can measure it with extraordinary precision. The same gravitational forces that create ocean tides also deform the rocky foundation of our planet, stretching and compressing the crust in a rhythm that has persisted for billions of years. This gravitational massage might seem too gentle to matter, but in the world of earthquake science, even tiny stresses can have enormous consequences. Rocks deep in Earth's crust exist in a delicate balance with enormous pressures and tensions held in check by friction and structural integrity. When the moon's gravitational pull adds just a small additional stress to an already unstable fault system, it can sometimes provide the final nudge that triggers a catastrophic release of energy. Scientists have found intriguing correlations between earthquake timing and lunar phases, particularly for the largest and most devastating earthquakes. The 2004 Indian Ocean earthquake that generated a devastating tsunami, the 2010 Chile earthquake, and the 2011 earthquake and tsunami in Japan all occurred near times of maximum tidal stress. While this might be coincidence, the pattern has appeared often enough to suggest that the moon's gravitational influence might help determine the precise timing of major seismic events. The mechanism isn't that the moon causes earthquakes. Tectonic forces building up over decades or centuries provide the real energy for seismic events. Rather, the moon acts like a trigger, adding just enough additional stress at the right moment to tip an already critical fault system past its breaking point. It's like adding one last grain of sand to a pile that's already on the verge of collapse. This tidal triggering effect is strongest for shallow earthquakes, where the moon's gravitational influence can more easily affect the stress patterns in crustal rocks. Deep earthquakes, occurring hundreds of miles below the surface, show weaker correlations with lunar cycles, because the moon's influence diminishes with distance and is overwhelmed by the enormous pressures of the deep Earth. The timing of the moon's influence on earthquake activity follows complex patterns related not just to lunar phases but also to the moon's distance from Earth and its position relative to the Sun. When the moon is at its closest approach to Earth, a point called perigee, its gravitational effects are about 40% stronger than when it's at its most distant point, called apogee. Some studies suggest that large earthquakes are more likely to occur when these enhanced tidal forces coincide with other stress-amplifying factors. But Earth isn't the only world where the moon influences seismic activity. The moon itself experiences moonquakes, seismic events triggered by a combination of tidal stresses from Earth's gravity and thermal expansion and contraction as the lunar surface alternately bakes in sunlight and freezes in darkness. Apollo seismometers left on the lunar surface during the 1960s and 1970s detected thousands of these moonquakes, revealing that our supposedly dead satellite is actually seismically active. Moonquakes come in several varieties, each telling a different story about the moon's internal structure and dynamics. Deep moonquakes occur about 700 miles below the lunar surface, apparently triggered by tidal stresses as the moon's slightly elongated shape responds to Earth's gravitational pull. These deep quakes happen in predictable cycles that match the moon's orbital period, providing strong evidence for tidal triggering. Shallow moonquakes are less frequent but more powerful, sometimes reaching magnitudes that would be felt strongly if they occurred on Earth. These quakes might be caused by the gradual cooling and shrinking of the lunar interior, creating stresses that occasionally release in sudden fault movements. The moon's lack of atmosphere and water means that seismic waves travel much more efficiently than on Earth, causing moonquakes to ring like a bell for hours after the initial event. Thermal moonquakes result from the extreme temperature changes that occur as different parts of the lunar surface move in and out of sunlight. Lunar rocks expand and contract by enormous amounts during the 14-day transition from lunar day to lunar night, creating mechanical stresses that occasionally release as small seismic events. These thermal quakes follow the lunar day-night cycle rather than tidal patterns, demonstrating how multiple forces contribute to the moon's seismic activity. Perhaps most intriguingly, impact moonquakes occur when meteoroids strike the lunar surface. The moon's lack of atmosphere means that space rocks of all sizes regularly crash into its surface, creating seismic signals that help scientists understand both the lunar interior structure and the flux of debris in our solar system. Some Apollo-era seismometers detected moonquakes caused by the deliberate crash landing of lunar modules, providing controlled experiments in lunar seismology. The study of moonquakes has revealed surprising details about the moon's internal structure. Unlike Earth, which has a molten outer core that dampens seismic waves, the moon appears to have a much smaller, possibly solid core surrounded by a partially molten layer. This structure allows seismic waves to travel efficiently through the lunar interior, making the entire moon ring like a struck bell during large quakes. Recent research has suggested that the moon might still be tectonically active, with gradual shrinkage causing the formation of new fault systems called lunar scarps. High-resolution images from lunar orbiters show these scarps cutting across relatively young features, indicating that moonquakes might still be reshaping the lunar surface today. This discovery challenges the traditional view of the moon as a geologically dead world, revealing it instead as a slowly evolving body still responding to both internal cooling and external tidal forces. The gravitational dance between Earth and Moon creates seismic effects that extend beyond simple tidal stresses. The Moon's orbit is slightly elliptical and tilted relative to Earth's equator, creating complex variations in tidal forces that change over multiple cycles. Some researchers have found correlations between earthquake activity and these longer-term tidal cycles, suggesting that the Moon's influence on seismic activity might be more complex than simple twice-daily tidal stresses. Volcanic activity might also respond to lunar influences, though the evidence is more controversial than for earthquakes. Some studies have found weak correlations between lunar phases and volcanic eruptions, particularly for volcanoes that are already in active or critical states. The proposed mechanism involves tidal stresses affecting magma chambers and conduit systems, potentially influencing the timing of eruptions that are already imminent for other reasons. The practical implications of lunar seismic triggering remain a subject of active research and debate. While the moon's influence might help determine the precise timing of some earthquakes, it doesn't provide a reliable method for earthquake prediction, because most seismic activity is controlled by much stronger tectonic forces. However, understanding tidal triggering mechanisms might help scientists better assess earthquake hazards in regions where fault systems are already under critical stress. Every time you feel the ground shake during an earthquake, sense the awesome power of tectonic forces reshaping our planet, or look up at the moon and wonder about its hidden influences on our world. You're experiencing the effects of gravitational forces that connect every particle of matter in the solar system. The moon's role in triggering earthquakes and creating moonquakes demonstrates that even in the apparently solid realm of rock and stone, celestial mechanics play out in ways that can reshape entire landscapes and occasionally remind us of the dynamic, interconnected nature of our cosmic neighborhood. The moon's role in the evolution of life. Have you ever stood by the ocean at twilight, watching the waves roll in and out with such perfect rhythm that it feels like the earth itself is breathing? There's something almost hypnotic about it, isn't there? The way the water advances and retreats, like a cosmic metronome keeping time with something far beyond our everyday awareness. What you're witnessing in that moment is one of the most profound partnerships in our solar system, a dance between our planet and its faithful companion, the moon, that has been choreographing the story of life itself for over 4 billion years. Most of us think of the moon as that beautiful distant lantern hanging in our night sky, perhaps inspiring poetry or romance. But rarely do we consider it as the invisible conductor, orchestrating the very conditions that made our existence possible. Yet, that's exactly what it is. The moon isn't just a pretty face in the heavens, it's been Earth's most important collaborator since almost the very beginning, quietly shaping everything from the length of our days to the complexity of life in our oceans. Imagine, if you will, a young Earth, roughly 4.5 billion years ago. Picture our planet as a restless teenager, spinning wildly on its axis, completing a full rotation in just 6 hours, instead of our familiar 24. The days were frantic, the nights brief, and the weather was absolutely chaotic. Winds howled across the surface at impossible speeds, and the climate swung between extremes that would make even our most dramatic weather patterns seem like gentle summer breezes. Into this tumultuous world came our moon, likely born from a collision so spectacular that it sounds like something from a cosmic epic, a Mars-sized object, which scientists have lovingly named Theia, after the Greek goddess, slammed into the young Earth with such force that it sent molten rock spiraling into space. This debris, still glowing with the heat of creation, gradually coalesced into the sphere we now call our moon. It was a violent birth, but from this cosmic catastrophe came the most stabilizing force our planet has ever known. The moon immediately began its work as Earth's great moderator, like a patient teacher working with an overly energetic student. It started to slow down our planet's frantic spinning. Through the invisible threads of gravitational force, the moon reached across the void and began to tug, gently but persistently, at Earth's rotating mass. It was a process that would take millions upon millions of years. But gradually, our planet's day began to stretch from those chaotic 6-hour cycles to something more civilized. This wasn't just a matter of convenience, it was literally a matter of life and death for any organisms trying to establish themselves on our world. You see, those early rapid rotations created temperature swings so extreme that they were like living inside a cosmic oven that kept switching between broil and freeze every few hours. No delicate chemistry of early life could survive such punishment. But as the moon's influence gradually slowed our rotation, something magical began to happen. Earth developed a more stable rhythm, a gentler alternation between day and night, that allowed temperatures to moderate and weather patterns to settle into something approaching predictability. Think of it like this. Imagine trying to grow a garden while someone keeps turning the lights on and off every few minutes, alternately blasting it with heat lamps and throwing ice cubes at it. Nothing could flourish under such conditions. But the moon gave Earth what every gardener knows is essential: a steady rhythm, reliable seasons, predictable cycles that life could depend upon. And that's exactly what happened. As Earth's rotation slowed and stabilized, the stage was set for one of the most remarkable developments in the history of our planet: the emergence of tides. Now, you might think tides are just a pleasant feature of coastal life, something that creates tide pools for children to explore, or determines when surfers can catch the best waves. But the truth is far more profound and beautiful than that. The earliest tides were nothing like the gentle, twice-daily rhythms we know today. With the moon much closer to Earth than it is now, perhaps only about 15,000 miles away compared to today's 240,000, the tidal forces were absolutely tremendous. Imagine tides not of a few feet, but of hundreds of feet, creating vast inland seas that would advance and retreat across enormous distances twice each day. These massive tidal zones became something extraordinary. They became laboratories of evolution. Picture these ancient shorelines as vast transitional spaces where the boundaries between sea and land blurred twice daily. Here, in these alternating worlds of wet and dry, marine organisms were presented with both challenges and opportunities, unlike anything that existed in the stable depths of the ocean or on the unchanging land. Some of these early life forms learned to survive periods of exposure to air, developing the first primitive adaptations that would eventually lead to lungs and air breathing. Others developed strategies for clinging to rocks during the violent tidal surges, innovations that would later evolve into the first appendages capable of locomotion on land. Still others learned to sense and respond to the rhythmic changes in their environment, developing some of the earliest biological clocks that would eventually become the circadian rhythms we carry within us today. It's almost poetic, isn't it? The theme, that distant silver sphere, was essentially creating a cosmic nursery where life could experiment with new ways of being. Every tide was like a gentle push, encouraging life to explore new possibilities, to venture into uncharted territories. to become more than it had been before. But the moon's influence on evolution goes even deeper than just creating these tidal laboratories. The gravitational relationship between Earth and Moon also helped establish what scientists call our planet's obliquity, the angle at which Earth tilts on its axis. This 23.5-degree tilt might seem like a small thing, just a slight lean in our planet's posture as it orbits the Sun, but it's actually the source of something we consider absolutely fundamental to life on Earth: our seasons. Without the Moon's stabilizing influence, Earth's tilt would vary wildly over geological time, swinging from nearly upright to lying almost on its side. Such dramatic changes would create climate chaos that would make adaptation nearly impossible for complex life forms. But the Moon acts like a cosmic gyroscope, keeping our planet's tilt stable and ensuring that our seasons remain predictable over the millions of years necessary for evolution to work its slow magic. And so, as we stand by that ocean at twilight watching those rhythmic waves that first caught our attention, we're witnessing the continuation of a story that began billions of years ago. Those tides aren't just moving water, they're carrying forward the legacy of the Moon's ancient gift to our planet. They're the gentle reminder of how a distant celestial companion quietly transformed a chaotic, spinning rock into a world capable of supporting the incredible diversity of life we see around us today. The Moon didn't just influence evolution in many ways, it made evolution possible. It gave our planet the gift of time, longer days that allowed complex chemistry to unfold, stable seasons that rewarded long-term adaptation, and rhythmic tides that created new ecological niches for life to explore. Every living thing on Earth, from the smallest microbe to the largest whale, from the deepest-rooted tree to the highest-flying bird, owes its existence in part to that quiet silver guardian that continues to watch over us each night. And that brings us to an even more fascinating question. If the Moon has been such a profound influence on the evolution of life, how did our ancestors, those early humans looking up at the night sky thousands of years ago, sense this deep connection? What made them feel that this celestial body was something more than just a bright light in the darkness? Why ancient civilizations worshipped the Moon? There's something almost magical about stepping outside on a clear night when the Moon is full, isn't there? Even in our modern world, with all its electric lights and digital distractions, that silver orb still has the power to make us pause, to look up, and to feel something. A sense of wonder perhaps, or connection to something larger than ourselves. If you've ever felt that pull, that mysterious sense that the Moon is somehow significant beyond just being a pretty light in the sky, then you've touched the same deep intuition that guided our ancestors for thousands of years, long before we had satellites and space missions, before we understood gravity and orbital mechanics, before we even knew that the Moon was another world rather than some divine lantern. Human beings across every continent and culture looked up at that changing face in the sky and recognized something profound. They didn't need telescopes to see that this celestial body was different from all the others. While the stars wheeled overhead in their eternal patterns and the sun blazed across the sky in its daily arc, the Moon alone seemed to live, to grow and shrink, to wax and wane, to die and be reborn in an endless, mesmerizing cycle. Imagine being one of those early observers, perhaps a member of a small tribe gathered around a fire 30,000 years ago. The night sky above you is darker and more brilliant than anything we can see today, unpolluted by artificial light, revealing the cosmos in all its breathtaking glory. But among all those points of light, one stands out not just for its brightness, but for its changeability. Night after night, you watch as this silver disk transforms itself, as predictable as the seasons but far more frequent, cycling through its phases roughly every 30 days. To those ancient minds, this wasn't just an interesting astronomical phenomenon, it was a revelation. Here was a celestial body that seemed to mirror the rhythms they observed in their own lives, and in the natural world around them. Women's bodies followed cycles of roughly the same length. The tides they observed along coastlines rose and fell in patterns that seemed connected to the Moon's changes. Even some of the animals they hunted appeared to behave differently during different phases of the Moon. The word month itself comes from moon, and this isn't a coincidence. It's a linguistic fossil that preserves the memory of humanity's first calendar system. Our ancestors realized that by watching the Moon's phases, they could track the passage of time in a way that was far more reliable than trying to count individual days. The Moon became humanity's first clock, our first calendar, our first way of organizing time into manageable, predictable units. But it was more than just practical timekeeping that made the moon sacred to so many cultures. There was something deeply psychological, almost mystical, about the way this celestial body seemed to embody the very essence of change and renewal. Think about it. Here was something that appeared to die completely, vanishing from the sky during the new moon phase, only to be reborn as a slender crescent a few nights later, growing steadily fuller until it blazed in perfect wholeness, then gradually diminishing again until it once more disappeared. To minds trying to make sense of life and death, of growth and decay, of the mysterious cycles that governed everything from crops to childbirth, the moon offered a perfect metaphor. It was the cosmic demonstration that death was not the end, but merely part of a larger cycle. The moon taught our ancestors that disappearance could be followed by return, that endings could be beginnings, that the apparent finality of death might be just another phase in an eternal rhythm. This is why so many ancient cultures associated the moon with goddesses, rather than gods. The lunar cycle seemed to mirror what they observed as the fundamental creative power of the feminine, the ability to bring forth new life, to nurture growth, and to embody the mysterious processes of transformation. The Greek goddess Selene, the Roman Diana, the Egyptian Isis, the Celtic Brigid. Across cultures that had no contact with each other, the moon consistently became associated with divine feminine energy. But the ancient reverence for the moon went beyond symbolism and metaphor. Our ancestors were remarkably skilled observers, and they began to notice correlations that modern science has only recently begun to understand. They observed that certain plants seemed to grow better when planted during specific moon phases. They noticed that some animals exhibited different behaviors during full moons versus new moons. They saw that ocean tides were strongest during certain lunar phases, and that these patterns seemed to influence everything from fishing success to the timing of storms. Were they right about all these correlations? Modern science suggests that some of their observations were indeed accurate, while others may have been cases of seeing patterns where none existed. But what's fascinating is how consistently different cultures, separated by vast distances and centuries, developed similar beliefs about lunar influence. It's as if the human mind is naturally attuned to recognize the moon's significance, even without understanding the precise mechanisms involved. The ancient Babylonians, those master astronomers of the ancient world, took lunar observation to extraordinary levels of sophistication. They discovered that eclipse cycles repeated in patterns they could predict, developing the Saros cycle, a period of about 18 years, 11 days, and 8 hours, after which eclipses would occur in nearly identical circumstances. This wasn't just academic knowledge for them, it was power. The ability to predict when the moon would be devoured by Earth's shadow made them seem almost godlike to their contemporaries. In ancient China, the lunar calendar became so fundamental to civilization that it governed everything from agricultural activities to imperial ceremonies. The Chinese concept of yin and yang, those complementary forces that govern all existence, was deeply influenced by lunar symbolism. The waxing moon represented yang energy, growth and expansion, while the waning moon embodied yin, the inward-turning energy of reflection and rest. This wasn't just philosophy, it was a practical guide for living in harmony with natural rhythms. The Maya took lunar observation even further, creating calendars of stunning accuracy that tracked not just the basic lunar cycle, but the subtle variations in the moon's orbit that cause eclipse cycles to shift over centuries. Their lunar calculations were so precise that they're still accurate today, thousands of years later. To the Maya, the moon wasn't just a timekeeper, it was one of the fundamental forces that structured reality itself. But perhaps the most poignant examples of ancient lunar reverence come from the megalithic cultures of Neolithic Europe. At sites like Stonehenge, Newgrange, and dozens of other stone circles and passage tombs, our ancestors aligned massive stones to frame the moon at specific points in its cycle. These weren't simple constructions, they represent thousands of hours of labor, careful observation and sophisticated understanding of lunar mechanics. Imagine the dedication required to build these monuments. Generations of people, working with nothing but stone tools and human muscle, moving blocks weighing many tons, all to create structures that would properly frame the moon's light at crucial moments in its cycle. They were creating cosmic theaters, sacred spaces, where human beings could feel more intimately connected to the rhythms that governed their world. The Aboriginal Australians, with perhaps the oldest continuous culture on Earth, developed dreamtime stories that encoded sophisticated understanding of lunar mechanics in mythological form. Their stories weren't just entertainment, they were mnemonic devices that preserved crucial knowledge about when to hunt certain animals, when to expect seasonal changes, and how to navigate by the stars and moon across vast distances. Even in cultures where the sun was the primary deity, the moon held a special place. The ancient Egyptians, despite their famous devotion to Re, the sun god, recognized Thoth as the god of the moon, wisdom, and timekeeping. They understood that while the sun provided the energy for life, it was the moon that provided the rhythm, the organizing principle that made complex civilization possible. What's remarkable is how many of these ancient insights align with what modern science has discovered about the moon's actual influence on Earth. Those tidal correlations that ancient cultures observed, we now know they're caused by the moon's gravitational pull. The biological rhythms that seem to follow lunar cycles, many of them are indeed real, though the mechanisms are more subtle than our ancestors could have imagined. The ancient worship of the moon wasn't primitive superstition. It was humanity's first attempt to understand and honor a cosmic relationship that truly does shape life on Earth. Our ancestors may not have known about gravitational forces or orbital mechanics, but they recognized something that modern, urban life sometimes makes us forget. We are not separate from the cosmos around us. We are part of a vast, interconnected system where distant celestial bodies continue to influence our daily lives in ways both obvious and subtle. And speaking of that influence, there are moments when the moon's power becomes dramatically, undeniably visible to everyone on Earth. Moments when its shadow literally transforms the world around us, creating experiences so profound that they've changed the course of human history. Lunar eclipses, and the shadows that change us. Picture this. You're going about your ordinary evening, perhaps preparing dinner or helping children with homework, when someone rushes in with an urgent message. Come outside, quickly. Something's happening to the moon. You step into the darkness, and there, hanging in the sky where the familiar full moon should be shining silver white, is something that makes your heart skip a beat. The moon is turning red. Not the warm romantic red of a harvest moon, but a deeper otherworldly crimson that seems to pulse with mysterious energy. You're witnessing a total lunar eclipse, one of nature's most spectacular demonstrations of the cosmic choreography that governs our solar system. In our modern world, we know exactly what's happening. We understand that Earth has moved directly between the sun and moon, casting our planet's shadow across the lunar surface. We can predict these events centuries in advance, down to the myriad of apps on our phones that will alert us when the next eclipse is coming. But strip away all that knowledge for a moment, and try to imagine what you would feel if you encountered this phenomenon with no scientific context whatsoever. To our ancestors, a lunar eclipse wasn't just an astronomical event, it was a cosmic emergency. Here was the moon, that reliable companion that had marked time and guided navigation for generations, suddenly being consumed by darkness or transformed into a blood-red orb that looked like something from the underworld. In cultures around the world, people developed explanations that reflected their deepest fears and most profound understanding of the forces that governed their lives. The ancient Chinese believed that a celestial dragon was devouring the moon, and they would rush outside banging pots and drums, shouting and making as much noise as possible to frighten the beast away. The Norse imagined wolves chasing the moon across the sky, occasionally catching and attempting to swallow it. Hindu mythology spoke of the demon Rahu, who had been beheaded by the gods, but continued to exist as a disembodied head that would periodically swallow the moon in revenge. These weren't just colourful stories, they were humanity's attempt to make sense of an event that challenged everything they thought they knew about the stability of the heavens. The moon was supposed to be constant, reliable, eternal. When it suddenly changed or disappeared, it suggested that the fundamental order of the universe might be more fragile than anyone had imagined. But here's what's truly fascinating. While the mythological explanations varied dramatically from culture to culture, the human response was remarkably consistent. Almost everywhere, lunar eclipses were seen as moments of cosmic vulnerability, times when the barriers between the ordinary world and the realm of magic, prophecy, or divine intervention became thin. People didn't just watch eclipses, they participated in them, through ritual, ceremony, and collective action designed to help restore cosmic balance. The Inca believed that during a lunar eclipse a jaguar was eating the moon, and the red color came from the jaguar's blood. But their response wasn't passive fear, it was active intervention. They would shoot arrows toward the moon, create loud noises, and shake their spears at the sky, all designed to drive away the celestial predator. In their worldview, humans had a responsibility to help maintain cosmic order, and an eclipse was a call to action. Ancient Mesopotamian astronomers, those careful observers who gave us some of our earliest scientific approaches to astronomy, recognized that eclipses followed predictable patterns. They discovered the Saros cycle, realizing that eclipses would repeat in very similar circumstances every 18 years, 11 days, and 8 hours. This knowledge gave them enormous power and prestige, as they could appear to predict when the gods would cause the moon to be devoured and reborn. But even with this scientific understanding, eclipses retained their emotional and spiritual power. The Babylonians saw them as omens that could predict the fate of kings and empires. A lunar eclipse might foretell the death of a ruler, the outcome of a battle, or the coming of famine or prosperity. The red color of the eclipsed moon was particularly ominous, interpreted as a sign that blood would be shed in the coming months. Christopher Columbus, that famous explorer, actually used knowledge of lunar eclipses as a tool of survival. In 1504, stranded in Jamaica and facing increasingly hostile relations with the local Taino people, who were reluctant to continue providing food for his crew, Columbus consulted his astronomical tables and realized that a total lunar eclipse was approaching. He arranged a meeting with the local chiefs and announced that his Christian God was angry with them for not helping his people, and that as a sign of divine displeasure, the moon would be taken away from the sky. When the eclipse began right on schedule, the Taino were terrified and begged Columbus to intercede with his god to restore the moon. Columbus retired to his cabin, ostensibly to pray, but actually to time the eclipse's duration using his hourglass. When totality was nearly over, he emerged and announced that his god had agreed to restore the moon in exchange for continued cooperation. The moon duly returned to its normal appearance, and Columbus's crew received the supplies they needed to survive until rescue arrived. This story illustrates something profound about the psychological power of eclipses. Even when we understand the science, even when we can predict them precisely, there's something about seeing that familiar face in the sky transform into something alien and otherworldly that touches something deep in our psyche. Modern people, who witness their first total lunar eclipse, often describe it in terms that echo ancient responses, feelings of awe, wonder, and even a touch of primal unease. The red color that appears during totality is particularly striking and mysterious, unlike a solar eclipse, where the moon appears as a crisp black silhouette against the sun's bright corona. A lunar eclipse transforms our satellite into something that seems to glow with its own eerie light. The deep red color comes from sunlight that has been filtered through Earth's atmosphere, the same phenomenon that makes sunrises and sunsets red. All the red light from every sunrise and sunset happening on Earth at that moment gets bent around our planet by atmospheric refraction and focused onto the moon's surface. In essence, during a total lunar eclipse, the moon is being illuminated by the combined light of every sunrise and sunset occurring on Earth simultaneously. It's one of the most poetic connections between our planet and its satellite. The moon, cut off from direct sunlight, instead receives the gentle, filtered glow of Earth's atmospheric envelope, colored by the same dust and moisture that creates the beauty of our terrestrial dawns and dusks. This scientific explanation doesn't diminish the emotional impact of the experience. If anything, it deepens it. To realize that the red light bathing the moon during an eclipse is essentially Earth's atmosphere made visible, projected across 250,000 miles of space onto our celestial companion, adds layers of meaning to an already profound experience. Modern eclipse chasers, people who travel the world to witness these events, often describe a sense of cosmic connection that transcends mere scientific interest. There's something about standing under a blood-red moon, knowing that you're witnessing the precise alignment of three worlds, that makes you feel both infinitesimally small and profoundly connected to the universe around you. The timing of lunar eclipses also creates their own special magic. Unlike solar eclipses, which are only visible along a narrow path and last for minutes at most, lunar eclipses can be seen from anywhere on Earth where the moon is above the horizon, and totality can last for over an hour. This accessibility means that lunar eclipses become shared experiences for entire hemispheres of humanity. Millions of people, all looking up at the same transformed celestial object at the same moment. In our interconnected modern world, lunar eclipses have become opportunities for global community. Social media fills with photographs and videos from around the world as the eclipse progresses, creating a real-time documentary of humanity's collective wonder. Time-lapse videos show the shadow creeping across the moon's face, transforming that familiar pattern of Lunar Maria and Highlands into something alien and mysterious. But perhaps the most profound aspect of lunar eclipses is how they demonstrate the dynamic nature of our solar system. In our daily lives, celestial objects seem fixed and eternal. The sun rises and sets, the moon goes through its phases, the stars wheel overhead in their familiar patterns. An eclipse breaks through this illusion of cosmic stasis and shows us that we're actually living on a planet that's hurtling through space at tremendous speed, part of a complex gravitational dance with other worlds. During a lunar eclipse, you can literally see Earth's shadow projected into space. Watch as our planet's silhouette moves across the moon's surface. It's a visceral reminder that we're not standing on solid, immovable ground, but rather on the surface of a sphere suspended in the void, casting shadows across hundreds of thousands of miles. And that shadow, that temporary transformation of the moon from silver to red, connects us to every human being who has ever looked up in wonder at the night sky, felt that same mixture of awe and slight unease, and recognized that we are part of something much larger and more mysterious than our everyday experience might suggest. The moon's influence on human consciousness and behavior doesn't end with these dramatic celestial events, though. There's a much more subtle, ongoing relationship between our satellite and our species, one that touches the most intimate aspects of human experience, the moon and human emotion, coincidence or connection. Have you ever noticed how some nights you find yourself lying awake, staring at the ceiling, your mind racing with thoughts that seem to come from nowhere? Or perhaps you've experienced one of those evenings where emotions feel particularly intense, where joy seems more vibrant, sadness cuts deeper, or restlessness makes it impossible to settle into your usual routines. The next morning, you might step outside and notice that the moon is full, hanging like a bright silver dollar in the dawn sky, and wonder, is there a connection? It's one of humanity's oldest questions, one that has been debated in emergency rooms and police stations, in poetry and philosophy, in scientific laboratories and around kitchen tables for centuries. Does the moon actually influence human emotion and behavior, or is it simply one of those persistent myths that feels true because we want it to be true? The belief in lunar influence on human behavior is so widespread and enduring that it has its own name, the lunar effect. Sometimes called the Transylvania effect after those old horror movies where werewolves transformed under the full moon. Hospital workers will tell you that emergency rooms get busier during full moons. Police officers often claim that crime rates spike. Teachers report that their students become more disruptive. Even the word lunacy derives from luna, the Latin word for moon, reflecting the ancient belief that mental illness waxed and waned with lunar cycles. But here's where the story becomes fascinatingly complex. When researchers have carefully analyzed hospital records, crime statistics, and other objective measures of human behavior, most studies have found no significant correlation with lunar phases. The full moon doesn't actually increase emergency room visits, crime rates, or psychiatric episodes beyond what you'd expect from random variation. So why does this belief persist so strongly? Why do so many people, including trained professionals who deal with human behavior every day, remain convinced that they've observed lunar effects? The answer might lie not in the moon's gravitational pull on our bodies, which is far too weak to overcome the gravitational effects of, say, the person standing next to you, but in something much more subtle and profound, the moon's influence on our circadian rhythms and the deep evolutionary connection between human consciousness and lunar cycles. Let's start with what we know is scientifically established. The human body operates on roughly 24-hour cycles called circadian rhythms, internal clocks that regulate everything from body temperature to hormone production to sleep patterns. These rhythms evolved over millions of years in response to the daily cycle of light and darkness created by Earth's rotation. But there's growing evidence that we also carry within us traces of much older rhythms, lunar rhythms that evolved during the billions of years when life on Earth was primarily influenced by tidal cycles. Many marine organisms still follow lunar rhythms with remarkable precision. Certain species of coral spawn only during specific moon phases. Some fish migrate according to lunar calendars. Grunion, those small silver fish that live along the California coast, time their spawning runs to coincide with the highest tides of spring and summer, which occur during new and full moons. These aren't learned behaviors. They're genetically programmed responses that have been fine-tuned over millions of years of evolution, Recent research has begun to uncover evidence that humans might retain some of these ancient lunar sensitivities. Studies have found that human sleep patterns can vary subtly with lunar phases, even when people are kept in laboratory conditions with no visual access to the moon. During full moon periods, some people take longer to fall asleep, sleep less deeply, and report more vivid dreams. The differences are small. We're talking about minutes, not hours, but they're statistically significant and consistent across different populations. Even more intriguingly, researchers have discovered that some people seem to maintain monthly biological rhythms that are roughly synchronized with the lunar cycle, even in our modern world of artificial lighting and climate-controlled environments. Women's menstrual cycles, which average about 28 days, are tantalizingly close to the lunar month of 29.5 days. While modern lifestyle factors have disrupted this synchronization for most women, studies of women living in traditional societies with minimal artificial lighting have found much stronger correlations between menstrual cycles and lunar phases. This suggests that the connection between human biology and lunar rhythms might be real, but much more subtle than the dramatic effects depicted in folklore and popular culture. Rather than turning us into werewolves or causing sudden personality changes, the moon's influence might be more like a gentle background rhythm that affects the quality of our sleep, the vividness of our dreams, or the subtle fluctuations in our energy levels throughout the month. But there's another layer to this story that's perhaps even more fascinating. The belief in lunar influence might be partly self-fulfilling, creating real effects through what psychologists call expectation bias. If you believe that full moons make you feel more emotional or restless, you might pay more attention to your emotional state during full moons, remembering instances that confirm your belief while forgetting times when you felt emotional but the moon wasn't full. This isn't to say that people are simply imagining things. The power of expectation to influence our actual experience of reality is well documented in psychology and neuroscience. If believing in lunar effects makes you more aware of your emotional states, more likely to engage in self-reflection, or more conscious of natural rhythms in your life, then that belief might actually improve your well-being, regardless of whether the moon is directly causing these effects. There's also the simple but profound effect of moon watching itself on human consciousness. Stepping outside on a clear night to look at the full moon is, in itself, a meditative act. It pulls us away from screens and artificial environments, connects us to the natural world, and provides a moment of perspective that can be genuinely transformative. The moon becomes a natural mandala, a focal point for contemplation that has been available to every human being who has ever lived. Indigenous cultures around the world have long recognized the moon as a powerful influence on human consciousness, but their understanding is often more nuanced than simple cause and effect. Many Native American traditions speak of the moon as a teacher, a source of wisdom that becomes available to those who take time to observe and listen. The Lakota concept of moontime refers not just to women's menstrual cycles, but to any period when a person feels called to turn inward, to reflect, to connect with deeper sources of knowledge and intuition. In traditional Chinese medicine, lunar cycles are seen as one of many natural rhythms that influence human health and emotional balance. Practitioners don't necessarily expect dramatic behavioral changes during full moons, but they might recommend different treatments or lifestyle adjustments based on lunar phases. Viewing the moon as one factor in a complex web of influences on human well-being. Perhaps the most beautiful aspect of the moon's relationship with human emotion isn't whether it causes specific behaviors, but how it serves as a mirror for our inner lives. The moon's phases, mu, waxing, full, waning, provide a natural metaphor for the cycles we all experience in our emotional and spiritual lives. Periods of growth and expansion, times of fullness and intensity, phases of release and letting go, moments of darkness and new beginnings. Many people find that consciously attuning to lunar rhythms helps them understand and navigate their own emotional patterns more skillfully. Not because the moon is controlling their emotions, but because lunar observation provides a framework for recognizing the natural cycles of expansion and contraction, activity and rest, that are part of healthy human functioning. The full moon, in particular, seems to serve as a natural checkpoint, a monthly reminder to pause and reflect on where we are in our lives. Whether this reflection leads to increased emotionality, restlessness, or spiritual insight might depend less on the moon's gravitational pull and more on what we bring to that moment of contemplation. There's something deeply satisfying about the idea that we're connected to cosmic rhythms, that our inner lives might be influenced by the same forces that move the tides and mark the passage of time. In a world that often feels disconnected from natural cycles, the possibility of lunar influence offers a bridge back to a more integrated way of being, where human consciousness is understood as part of the larger web of relationships that connect all life on Earth. And speaking of connections between human consciousness and lunar rhythms, there's one aspect of our daily experience where this relationship becomes particularly vivid and mysterious. In the realm of sleep, dreams and the phases of the moon. There's something almost mystical about those nights when sleep seems to dance just beyond your reach, isn't there? You lie in bed, feeling perfectly tired, yet your mind hums with an energy that makes rest impossible. Your thoughts seem sharper, more vivid than usual, and when you finally do drift off, your dreams arrive with unusual intensity, rich with symbolism, emotion, and imagery that lingers long after you wake. The next morning, as you stumble through your day feeling simultaneously exhausted and oddly energized, you might notice that bright full moon still visible in the dawn sky, and wonder if there's more than coincidence at work. For thousands of years, humans have noticed connections between lunar phases and the quality of their sleep, long before we had electric lights to disrupt our natural rhythms. Before we understood the science of circadian biology, our ancestors organized their lives around the moon's cycle, recognizing that different phases seem to bring different qualities of rest, dreaming, and nocturnal experience. Modern sleep research has begun to uncover evidence that these ancient observations might have been more accurate than we previously thought. In controlled laboratory studies, where participants are kept in windowless rooms with no access to natural light or knowledge of lunar phases, researchers have found subtle but consistent variations in sleep patterns that correlate with the moon's cycle. During full moon periods, people tend to take about 5 minutes longer to fall asleep, sleep for roughly 20 minutes less overall, and spend less time in the deepest phases of sleep. These effects are small. We're not talking about the dramatic sleep disruptions portrayed in werewolf movies, but they're statistically significant and remarkably consistent across different populations. Even more intriguingly, the changes seem to begin several days before the full moon and persist for several days afterward, suggesting that our bodies might be responding to the gradually increasing and then decreasing lunar illumination rather than just the peak moment of fullness. But what's causing these effects? The moon's gravitational pull on our bodies is far too weak to account for such changes. After all, the person sleeping next to you exerts more gravitational influence on your body than the moon does. Instead, researchers suspect that we might be responding to subtle changes in natural light levels, or to even more mysterious mechanisms that we're only beginning to understand. You see, even though we live in a world saturated with artificial light, our bodies still carry the ancient evolutionary programming that helped our ancestors survive in environments where the moon was often the only source of illumination after sunset. A full moon can be surprisingly bright, bright enough to read by, bright enough to navigate forest paths, bright enough to extend the useful day for hunting, gathering, or social activities. For millions of years, these monthly cycles of increased nighttime illumination would have been crucial for survival. During new moon periods, when nights were truly dark, it made sense to sleep deeply and conserve energy. But during full moon phases, when the landscape was bathed in silver light, there were opportunities and dangers that required a different kind of vigilance. Perhaps our ancestors developed the ability to sleep more lightly during full moons, to be more easily awakened by sounds that might indicate the approach of predators or prey. This evolutionary perspective suggests that what we experience as lunar insomnia might actually be an ancient survival mechanism, a genetically programmed increase in alertness that helped our ancestors take advantage of moonlit nights while remaining ready to respond to threats or opportunities. The restless energy that some people feel during full moons might be the echo of countless generations who used these bright nights for activities that required enhanced awareness and quick reflexes. The quality of dreams also seems to shift with lunar phases, though this is an area where scientific research blends with centuries of anecdotal observation and cultural wisdom. Many people report that their dreams become more vivid, more memorable, and more emotionally intense during full moon periods. Dream journals kept over months or years often show patterns that correlate with lunar cycles, with peak dream activity occurring not just during full moons, but during the transition periods, as the moon waxes toward fullness and then wanes toward darkness. Indigenous cultures around the world have long recognized these connections between lunar phases and dreaming. Many Native American traditions speak of the full moon as a time when the veil between the waking world and the dream world becomes thinner, when prophetic dreams are more likely to occur, and when the messages received in sleep carry special significance. The Seneca people call the full moon the time when dreams walk, recognizing it as a period of heightened spiritual receptivity. In traditional Chinese medicine, different lunar phases are associated with different qualities of dreaming and different types of messages that might be received through sleep. The new moon is seen as a time for dreams, new beginnings and fresh insights, while the full moon brings dreams of completion, revelation, and emotional release. The waxing moon encourages dreams of growth and expansion, while the waning moon supports dreams of letting go and healing. These traditional understandings suggest that lunar influences on sleep and dreaming might be less about disruption and more about natural rhythm cycles of rest and activity, receptivity and alertness, that helped our ancestors live in harmony with the larger rhythms of the natural world. Rather than seeing full moon insomnia as a problem to be solved, some people find it helpful to think of it as an invitation to engage with different qualities of consciousness. Modern sleep researchers have discovered that artificial light exposure, particularly blue light from screens and LED bulbs, can significantly disrupt our natural sleep patterns by suppressing the production of melatonin, the hormone that regulates our sleep-wake cycles. Interestingly, moonlight has a very different spectral composition than artificial light. It's much redder and warmer, similar to candlelight or firelight. This means that exposure to actual moonlight is far less likely to disrupt sleep than exposure to the bright blue rich artificial lighting that fills our modern environments. Some people have experimented with aligning their sleep schedules more closely with natural lunar rhythms, using blackout curtains during new moon periods to create deeper darkness, and allowing moonlight to filter into their sleeping spaces during full moons. They report that this approach can lead to more restful sleep overall, even if individual full moon nights involve less total sleep time. The idea is to work with lunar rhythms rather than against them, recognizing that our bodies might naturally want different amounts and qualities of sleep during different phases of the month. The relationship between lunar phases and dreams becomes even more fascinating when we consider the role of REM sleep, the stage when most vivid dreaming occurs. Research suggests that REM sleep patterns might be subtly influenced by lunar cycles, with some people experiencing changes in REM duration and intensity that correlate with moon phases. Since REM sleep is crucial for emotional processing, memory consolidation, and creative problem-solving, lunar influences on this sleep stage could have far-reaching effects on mental and emotional well-being. There's also emerging research on something called moon sleep, the phenomenon where people naturally wake up during the night when the moon is visible, even when sleeping indoors with no direct exposure to moonlight. This might be related to extremely subtle changes in electromagnetic fields, air pressure, or other environmental factors that we don't yet fully understand. Some researchers speculate that humans might possess a kind of magnetic sensitivity, similar to that found in migrating birds and sea turtles, that allows us to unconsciously detect lunar influences. The timing of lunar effects on sleep also reveals interesting patterns. The effects often begin during the waxing gibbous phase, when the moon is about 3/4 full, and continue through the waning gibbous phase several days after the full moon. This suggests that our sleep systems might be responding to the gradual increase and decrease in nighttime illumination rather than just the peak moment of lunar fullness. For people who find their sleep disrupted during full moon periods, sleep specialists sometimes recommend embracing rather than fighting these natural rhythms. Instead of lying in bed frustrated by insomnia, they suggest using full moon nights for gentle activities that honor the body's apparent desire for wakefulness. Reading, journaling, meditation, or quiet creative work. The key is to avoid stimulating activities or bright artificial lights that might further disrupt sleep patterns. Many cultures have developed beautiful rituals around full moon sleep patterns. Some Buddhist traditions include moon-watching meditation, where practitioners sit quietly observing the full moon as a form of contemplative practice. Indigenous Australian cultures speak of moon dreaming, a state of consciousness that occurs during lunar-influenced sleep disruptions, when the boundaries between sleeping and waking awareness become fluid. The relationship between moon phases and sleep might also explain some of the emotional effects that people associate with lunar cycles. Sleep quality has profound effects on emotional regulation, stress resilience, and mental clarity. If the moon does subtly influence our sleep patterns, then the emotional and behavioral effects that people notice during different lunar phases might be indirect consequences of these sleep changes, rather than direct lunar influences on mood or behavior. What's particularly beautiful about this relationship is how it connects us to the natural world in ways that transcend our modern, artificially lit environments. Even when we can't see the moon, because of clouds or urban light pollution. Even when we're sleeping in windowless rooms, our bodies might still be responding to ancient rhythms that connect us to the celestial dance happening overhead. This lunar influence on our sleep and dreams serves as a gentle reminder that we are not separate from the natural world around us. The same gravitational forces that move the oceans also flow through our bodies. The same cycles that have guided life on Earth for billions of years continue to whisper their ancient wisdom through our patterns of rest and wakefulness, through the quality of our dreams and the rhythms of our deepest biological processes. And speaking of those gravitational forces that move the oceans, this brings us to one of the moon's most visible and powerful influences on our planet: lunar gravity and the shape of our oceans. Have you ever stood at the edge of the ocean during low tide, looking out at the exposed sand flats and tide pools that just hours earlier were covered by deep water, and wondered where all that water went? Or perhaps you've watched the tide come in, advancing up the beach with such steady determination that it seems almost alive, breathing in and out with a rhythm that feels both ancient and eternal. What you're witnessing in these moments is one of the most visible demonstrations of the moon's power, a gravitational embrace that reaches across nearly 250,000 miles of space to literally reshape the surface of our planet twice every day. The story of tides is really the story of a cosmic dance between three partners: the Earth, the Moon, and the Sun. But it's the Moon that leads this dance. Its gravitational pull, creating the rhythm that moves roughly 70% of our planet's surface in a gentle eternal waltz. To understand just how remarkable this is, imagine trying to move an entire ocean using only the invisible force of gravity reaching across the vacuum of space. It sounds impossible, yet it happens so reliably that we've built civilizations around its rhythm. The basic mechanics of tides are beautifully simple, even though the reality is fascinatingly complex. The moon's gravity pulls on everything on Earth, but it pulls slightly harder on things that are closer to it. Since Earth is a sphere, the parts of our planet that face the moon are about 8,000 miles closer to it than the parts that face away. This difference might seem tiny on a cosmic scale, but it's enough to create what scientists call a tidal force, a gentle but persistent tug that's strongest on the side of Earth facing the moon. Now here's where it gets interesting. Water, being liquid, responds to this gravitational gradient much more readily than solid rock. The oceans on the moon-facing side of Earth get pulled slightly toward our satellite, creating what we call a tidal bulge. But there's also a corresponding bulge on the opposite side of the planet, and this is where many people's intuition goes astray. You might expect the far side to have low tides, since it's farther from the moon, but actually, it experiences high tides too. This happens because the moon is pulling the solid Earth away from the water on the far side. Think of it like this. Imagine you're in an elevator that suddenly starts accelerating upward. You feel pressed toward the floor. Not because gravity got stronger, but because the floor is accelerating away from you. Similarly, on the far side of Earth, the water experiences a relative bulge, because the solid planet is being pulled toward the moon slightly more than the water is. The result is that Earth wears its oceans like a slightly stretched football, with bulges on both the moon-facing and the far sides. As our planet rotates once every 24 hours, different locations pass through these bulges, experiencing the rise and fall we know as high and low tides. Most coastal areas experience 2 high tides and 2 low tides each day, separated by about 6 hours and 12 minutes. The extra 12 minutes accounting for the fact that the moon is also moving in its orbit around Earth. But the sun complicates this elegant dance in fascinating ways. Our star is much more massive than the moon, but it's also much farther away, so its tidal effect on Earth is about half as strong as the moon's. When the sun, moon, and Earth align during new and full moon phases, their gravitational effects add together, creating what we call spring tides. These are the highest high tides and the lowest low tides of each month, when the tidal range is at its maximum. When the sun and moon are at right angles to each other during the first and third quarter moon phases, their gravitational effects partially cancel out, creating neap tides with smaller tidal ranges. The word neap comes from an Old English word meaning without the power of advancing, which beautifully captures how these tides seem less energetic, less dramatic than their springtide cousins. The Bay of Fundy between New Brunswick and Nova Scotia experiences some of the most extreme tides in the world, with water levels changing by more than 50 feet between high and low tide during spring tide events. Standing in this bay during low tide, you can walk on the ocean floor in areas that will be covered by 5-story buildings worth of water just 6 hours later. It's like watching the Earth breathe, with a rhythm set by our celestial companions. These dramatic tidal ranges occur because the Bay of Fundy's shape and depth create what's called tidal resonance. The bay acts like a massive bathtub that's being rocked at just the right frequency to amplify the tidal movements. It's similar to how you can create large waves in a bathtub by moving your hand back and forth at just the right rhythm. The bay's natural oscillation period matches the tidal period, amplifying relatively small tidal forces into spectacular movements of water. But tides aren't just about moving water up and down beaches. They're one of the most powerful forces shaping coastal landscapes around the world. Tidal currents can move sediment, carve channels, build barrier islands, and create entirely new landforms over time. The famous Mont Saint-Michel in France is surrounded by tidal flats that flood and drain so dramatically that what seems like an island at high tide becomes accessible by foot at low tide, though only for those who understand the timing and are prepared to move quickly when the tide turns. The moon's gravitational influence on Earth's oceans also creates more subtle, but equally important effects. Tidal currents help mix ocean waters, distributing nutrients, oxygen and heat around the globe. This mixing is crucial for ocean health and plays an important role in regulating Earth's climate. The energy of tidal movements also creates turbulence that helps maintain the vertical circulation patterns that keep our oceans oxygenated and biologically productive. Scientists estimate that tidal friction, the energy lost as moving water encounters resistance from the ocean floor and coastlines, is gradually slowing Earth's rotation and causing the moon to spiral slowly away from us. The energy for tides has to come from somewhere, and that somewhere is the rotational energy of the Earth-Moon system. This means that our days are getting slightly longer over geological time, and the moon is moving about 1.5 inches farther away each year. This might seem like purely academic knowledge, but it has profound implications for the future of life on Earth. The tidal forces that helped create the conditions for life's evolution are slowly weakening. Billions of years from now, if Earth and the moon both survive the eventual death of our sun, tides will be much weaker, and our planet will be tidally locked to the moon, with one side permanently facing our satellite and the other side forever turned away. But for now, we live in a golden age of tides, when the moon is close enough to create spectacular tidal ranges, but far enough away to allow for the kind of stable, predictable patterns that life has learned to depend upon. Every tide is a reminder of the gravitational threads that connect our planet to its celestial companion, threads that are invisible but strong enough to move entire oceans. Modern humans often live so far from natural coastlines that we forget about tides entirely, but they continue their ancient rhythm whether we notice them or not. In a world where so much seems chaotic and unpredictable, there's something deeply comforting about the reliability of tidal cycles. No matter what's happening in human affairs, no matter how much our technology changes the world around us, twice each day, the moon calls to the oceans, and twice each day, they answer. And the moon's protective influence on our planet extends far beyond the rhythmic movement of tides. The moon's role in protecting Earth from asteroids. Imagine looking up at the moon through a telescope for the first time and being struck, not by its beauty but by its scars. That pockmarked surface, covered with craters large and small, tells a story that's both violent and protective. The story of our satellite standing guard over Earth like a cosmic shield, taking hit after hit from the debris of space, so that we don't have to. Every crater on the moon's surface represents a potential catastrophe that never reached our planet, an asteroid or comet that met its end in lunar rock rather than terrestrial catastrophe. When you really start to contemplate the moon's cratered face, it becomes clear that space is not the empty void we sometimes imagine. It's actually quite crowded with leftover debris from the solar system's formation, chunks of rock and ice ranging in size from pebbles to mountains, all following their own elliptical paths around the sun. Some of this debris has been wandering the solar system for billions of years, occasionally crossing paths with planets and moons in encounters that can be spectacular and devastating. Earth sits right in the middle of this cosmic shooting gallery, but we're not defenseless. We have several layers of protection, and the moon is one of the most important. Think of it as our planetary bodyguard, not actively deflecting incoming objects like some science fiction force field, but simply being there, with its substantial mass and gravitational influence, changing the trajectories of objects that might otherwise have Earth in their crosshairs. The moon's protective role works in several fascinating ways. Most obviously, it acts as a gravitational vacuum cleaner, capturing some objects that might otherwise hit Earth. The moon's gravity reaches out much farther than its physical size, creating what astronomers call its gravitational sphere of influence. Any asteroid or comet that wanders into this sphere gets its trajectory altered, and some get captured entirely, meeting their end in spectacular impacts that add new craters to the lunar landscape. But the moon's protection extends far beyond just catching the occasional asteroid. Its gravitational influence helps stabilize the entire inner solar system, affecting the orbital paths of debris throughout the Earth-Moon region. Some objects that might have eventually found their way to Earth instead get their orbits altered by lunar gravity, sending them careening off into different parts of the solar system or into the sun. To understand just how significant this protection is, we need to look at the evidence written across the moon's surface. The lunar highlands, those bright, mountainous regions that dominate the moon's far side, and much of its near side, are absolutely saturated with craters. Some are huge, like the South Pole Aitken Basin, which is over 1,500 miles across, and represents one of the largest impact craters in the solar system. Others are tiny, just a few feet in diameter, representing impacts from smaller debris. What's remarkable is that this cratering represents just the impacts that have occurred since the moon's surface solidified. The moon doesn't have an atmosphere to burn up incoming debris, and it doesn't have geological processes like plate tectonics or erosion to erase the evidence of impact. So every impact that has occurred over the past 4 billion years is still visible on the lunar surface, creating a detailed record of the bombardment that both the moon and Earth have experienced. Scientists estimate that for every crater on the moon, Earth would have received about 20 impacts from similar-sized objects if the moon weren't there to intercept some of them and alter the trajectories of others. This means that the moon has prevented thousands of potentially catastrophic impacts on our planet over the course of geological history. Some of the craters on the moon are so large that they represent impacts that would have been global catastrophes if they had hit Earth instead. The Orientale Basin, for example, was created by an impact so massive that it sent shock waves completely around the moon, creating concentric rings of mountains that are still visible today. An impact of similar magnitude on Earth could have caused mass extinctions, dramatically altered our climate, or even sterilized our planet's surface entirely. But the moon's protective role becomes even more significant when we consider the timing of these impacts. During the first billion years of the solar system's history, there was a period called the Late Heavy Bombardment, when the inner planets were subjected to an intense barrage of asteroids and comets. This bombardment was so severe that it would have made the surface of Earth uninhabitable for complex life forms. The moon bears the scars of this ancient catastrophe in the form of the massive impact basins that we can still see today. The dark areas on the moon that we call Maria Latin for seas, though they contain no water, are actually ancient lava flows that filled in some of the largest impact craters created during this period. Each of these Maria represents multiple impacts so massive that they cracked the moon's crust and allowed molten rock to flow up from the interior. If Earth had taken the full brunt of the late heavy bombardment without the moon's protection, it's entirely possible that life as we know it could never have evolved. The constant rain of large impacts would have repeatedly sterilized Earth's surface, boiling away oceans and destroying any complex molecules that might have been trying to organize themselves into living systems. The moon's protection continues today, though the bombardment rate is much lower than it was during the early solar system. Modern telescopes and space missions have allowed us to witness recent impacts on the moon, providing real-time evidence of our satellite's ongoing protective role. In 2013, NASA's Lunar Impact Monitoring Program recorded an impact flash on the moon, bright enough to be seen with small telescopes from Earth. The impacting object was probably only about the size of a small boulder, but it hit the lunar surface with the energy of several tons of TNT. If that same object had hit Earth, it would have been completely burned up in our atmosphere, creating a brilliant meteor but no lasting damage. But larger objects that might pose a threat to Earth often get intercepted by the moon instead. Amateur astronomers regularly observe impact flashes on the lunar surface, each one representing debris that won't be heading our way. The moon also provides protection through what scientists call orbital resonances. The gravitational relationship between Earth and the moon creates stable and unstable zones throughout the inner solar system. Some of these zones trap potentially hazardous objects, while others eject them from the Earth-Moon system entirely. It's like having a cosmic traffic control system that diverts dangerous objects away from populated areas. Recent computer simulations have shown that without the moon, Earth would be hit by asteroids and comets at least twice as often as it currently is. This might not sound like a huge difference, But over geological timescales, it adds up to thousands of additional impacts, including many that would be large enough to cause regional or global devastation. The dinosaur-killing asteroid that hit Earth 66 million years ago, the one that created the Chicxulub crater in Mexico and ended the Cretaceous period, was probably about 6 miles in diameter. The Moon has several craters that were created by objects even larger than this. The Imbrium Basin, for example, was likely created by an object perhaps 50 miles across. If an impact of that magnitude had hit Earth instead of the Moon, it would have been an even more catastrophic extinction event than the one that ended the dinosaurs. But the Moon's protective influence extends beyond just intercepting large, potentially catastrophic objects. It also affects the smaller debris that creates meteor showers. Some meteor streams that might otherwise pose a hazard to Earth get their orbits altered by lunar gravity, reducing the intensity of potentially dangerous meteor storms. The Moon even protects us from some comets, those icy visitors from the outer solar system that can be particularly unpredictable and dangerous. Comets often have highly elliptical orbits that bring them close to the Sun, and then send them back out to the cold outer reaches of the solar system. Some of these orbits intersect the Earth-Moon system, and lunar gravity can alter their paths in ways that reduce the likelihood of future Earth impacts. What makes this protection even more remarkable is that it's completely automatic and has been operating for billions of years without any conscious guidance or intervention. The Moon doesn't choose to protect Earth, it's simply following the laws of physics as it orbits our planet. But the net effect is as if we have a vigilant guardian that never sleeps, never stops watching, and never fails in its duty to help keep us safe from the dangers of space. This protective relationship is yet another way that the Moon has been essential to the development and continuation of life on Earth. Without it, our planet would be a much more dangerous place, subjected to more frequent and more severe impacts that could disrupt the delicate balance of conditions that complex life requires. And yet, this protection comes with a poignant realization: the very features that make the Moon such an effective shield, its lack of atmosphere, its geological stability, its crater-preserved surface, also make it an alien and seemingly lifeless world, so different from the vibrant, protected planet it guards. But what would happen if this ancient guardian were suddenly gone? What if we woke up one morning to find the Moon had vanished from our sky? What would happen if the Moon disappeared? Picture this. You wake up tomorrow morning, stretch, and wander outside for that first glimpse of dawn. But something feels different. Where you expect to see the Moon, perhaps a pale crescent, hanging in the brightening sky, or the ghostly outline of a full moon fading as the sun rises, there's only empty space. The Moon, Earth's faithful companion for over 4 billion years, has simply vanished into the cosmic void. How long would it take you to notice? And what would happen to our world in the hours, days, and years that followed? At first, you might think you're simply looking in the wrong direction, or that morning clouds are playing tricks on your eyes. But as the day progresses and night falls, the absence would become undeniable, like discovering that a dear friend has disappeared without so much as a goodbye note. The night sky would transform in ways that would be immediately obvious to anyone who has ever glanced upward after sunset. Stars that are normally washed out by moonlight would suddenly shine with brilliant clarity, like diamonds scattered across black velvet. The Milky Way, that faint river of light that's often invisible in our moon-brightened skies, would blaze across the heavens with spectacular intensity. It would be breathtakingly beautiful, but also deeply unsettling. The universe would feel both more magnificent and more lonely at the same time. But this visual change would be just the beginning of our story. Within hours, people living near the ocean would notice something far more dramatic and alarming. The tides, those reliable rhythms that have shaped coastal life for millennia, would begin to behave in completely unprecedented ways. It's like the ocean itself had forgotten how to breathe. Think of the Moon as the conductor of Earth's greatest orchestra, and the tides as the music it creates. Without the Moon's gravitational baton, the primary force driving our tides would simply disappear, leaving only the Sun's much weaker tidal influence. Like trying to conduct a symphony with a toothpick instead of a conductor's wand. The immediate result would be chaos along every coastline on Earth. Areas that experience dramatic tidal ranges, like the Bay of Fundy with its 50-foot tides that can fill a 5-story building, or Mont Saint-Michel in France, with its rapidly advancing tidal bore that transforms the landscape twice daily, would see their tidal ranges collapse to perhaps a tenth of their normal size. Fishing boats that depend on high tides to reach their harbors would find themselves stranded on mudflats like beached whales. Coastal ecosystems that have evolved around predictable tidal cycles for millions of years would be thrown into biological pandemonium. Imagine all the creatures whose lives are intimately connected to these tidal rhythms. They're like dancers who've been practicing the same choreography for eons, only to have the music suddenly change. Grinion fish, which time their spawning runs to the highest tides of the month, with the precision of Swiss clockwork, would find themselves trying to mate on beaches that the water no longer reaches. It's like showing up to a pool party, only to find an empty concrete pit. Fiddler crabs, whose elaborate courtship displays are synchronized with tidal cycles, would continue their ancestral dances on mudflats that remain permanently exposed. Countless species of shorebirds that time their migrations to coincide with specific tidal conditions would arrive at feeding grounds that no longer exist in their expected form, like travelers arriving at a train station where all the schedules have been permanently cancelled. But the ecological disruptions would ripple far beyond the immediate coastlines, like stones thrown into a pond. Many fish species depend on tidal currents to transport their larvae to appropriate nursery areas. Without these liquid highways, entire generations of marine life could find themselves in the wrong places at the wrong times, triggering cascading effects throughout ocean food webs like a biological domino effect. Commercial fisheries that depend on predictable tidal patterns for everything from navigation to fishing strategies would face unprecedented challenges. It would be like trying to farm without knowing when the seasons will change. Now, here's where things get really interesting, and a bit more subtle, but ultimately more profound. The changes to Earth's rotation would unfold like a slow-motion catastrophe spanning millions of years, without the moon's gravitational drag gradually slowing our planet's spin, like a cosmic brake pedal being slowly pressed. Earth would maintain its current rotational speed indefinitely. This might sound like a good thing at first, no more gradually lengthening days, right? But the implications are actually quite significant, like removing a single card from a house of cards and watching the whole structure slowly wobble. The tidal friction that's currently slowing Earth's rotation also helps maintain the dynamic relationship between our planet's solid interior and its liquid core. This relationship is crucial for generating Earth's magnetic field, that invisible shield that protects us from harmful solar radiation and helps maintain our atmosphere. Over geological timescales, the loss of lunar tidal forces could affect the strength and stability of Earth's magnetic field. A weaker magnetic field would allow more cosmic radiation to reach Earth's surface, and could lead to gradual atmospheric loss, particularly of lighter gases like hydrogen, that are constantly being stripped away by solar wind. It's like having a leaky umbrella in a cosmic rainstorm. But perhaps the most dramatic long-term consequence would involve something called axial stability, and this is where our story takes a truly wild turn. Currently, the moon acts like a massive gyroscope in space, keeping Earth's rotational axis relatively stable at its current 23.5-degree tilt. This tilt is what gives us our seasons, and its stability over millions of years has been crucial for the evolution of complex life. The moon is essentially Earth's cosmic stabilizer, like training wheels on a bicycle preventing us from wobbling out of control. Without the moon's stabilizing influence, Earth's axial tilt would begin to vary chaotically over periods of millions of years, swinging from nearly upright to lying almost on its side, like a spinning top, running out of momentum. These variations would create climate changes so extreme that they would make our current concerns about global warming seem like a gentle breeze compared to a hurricane. When Earth's axis tilted toward its maximum angle, polar regions would experience months of continuous sunlight followed by months of total darkness, while equatorial regions would face dramatically different seasonal patterns. Ice ages would become more frequent and more severe, and the stable climate patterns that have allowed human civilization to develop would be completely disrupted. The psychological and cultural effects of the moon's disappearance would be immediate and profound, like losing a family member who's been part of every important moment in human history. Humans have used the moon as a timekeeper for thousands of years. The word month comes from moon, and many of our cultural and religious traditions are built around lunar cycles, like scaffolding supporting a building, the Islamic calendar, the Jewish calendar, and many other traditional timekeeping systems would suddenly become meaningless. Festivals, holidays, and ceremonies that have been celebrated for millennia would lose their astronomical foundation. It would be like trying to celebrate Christmas without winter, or Easter without spring. Agricultural societies that still plant and harvest according to lunar phases would find themselves without their traditional guide. While modern science questions some of these lunar agricultural practices, the cultural disruption would be enormous for communities that have organized their lives around these ancient rhythms for generations. The loss of moonlight would have practical consequences that we rarely consider in our electrically illuminated world. For most of human history, moonlight was the primary source of illumination for nighttime activities, nature's own streetlight. Even today, in areas without reliable electricity, full moon nights are times when communities can extend their active hours, when travel is safer, and when social activities can continue after sunset. Wildlife that has evolved to take advantage of moonlit nights would face serious challenges. Many nocturnal predators rely on moonlight for hunting, while prey species have developed strategies for avoiding predation during bright nights. The complete absence of significant nighttime illumination would disrupt predator-prey relationships that have been stable for millions of years. Perhaps most poignantly, the moon's disappearance would rob humanity of one of our most profound sources of wonder and inspiration. The moon has inspired countless poems, songs, paintings, and stories. It has served as a symbol of romance, mystery, and the human desire to explore beyond our earthly boundaries. Lovers would no longer meet by moonlight, and children would grow up in a world where once in a blue moon would be a meaningless phrase, referring to something that could never happen. But perhaps the most profound loss would be the end of the evolutionary partnership that has shaped life on Earth for billions of years. The moon has been our planet's companion through the emergence of the first simple cells, the development of complex multicellular life, the colonization of land by plants and animals, and the evolution of human consciousness itself. Every living thing on Earth today is the product of evolution that occurred under the moon's influence. The tidal rhythms that helped life transition from sea to land, the seasonal stability that allowed complex ecosystems to develop, the protection from asteroid impacts that prevented repeated mass extinctions. All of these lunar gifts have been woven into the very fabric of terrestrial life. Like threads in an ancient tapestry, the moon's disappearance would mark the end of an era that began with the violent collision that created our satellite over 4 billion years ago. It would be the severing of one of the most ancient and important relationships in our solar system, leaving Earth to face an uncertain future without its celestial partner, a planet suddenly alone in the cosmic dance, trying to remember the steps to a waltz it can no longer hear, the eternal bond. How Earth and Moon will end together. But let's step back from this imaginary catastrophe and consider a different question, one that's both more hopeful and more melancholy. What if the moon never disappeared? What if, instead, we follow the real story of Earth and Moon to its natural conclusion, billions of years in the future? This is a love story, written in the language of physics and played out on a cosmic time scale. The tale of two celestial bodies locked in an eternal dance that will end only when the music of the universe itself grows quiet. Right now, as you're listening to these words, something remarkable is happening overhead. The moon is slowly drifting away from Earth at about 3.8 centimeters per year, roughly the same rate that your fingernails grow. It's such a tiny distance that you'd never notice it in a human lifetime. But over millions and billions of years, this gradual separation tells an epic story of cosmic evolution. Think of it like this. Imagine Earth and Moon as dance partners, who started their waltz pressed close together, spinning wildly in a passionate embrace. Over time, their dance has slowed and become more dignified, and they've moved apart, just enough to give each other breathing room. But they're still dancing together, still connected by invisible threads of gravity that neither time nor distance can completely break. This slow separation isn't random, it's the result of the same tidal forces we discussed earlier, but working in reverse. Just as the moon pulls on Earth's oceans to create tides, Earth pulls back on the moon with equal force. This gravitational tug-of-war has been reshaping both worlds for billions of years, like two sculptors working on each other simultaneously. Here's how the cosmic choreography works. As Earth's tidal bulges rotate slightly ahead of the moon due to friction and other factors, they pull the moon forward in its orbit. This extra energy causes the moon to spiral slowly outward, like a figure skater extending their arms to slow their spin. Meanwhile, this same process gradually slows Earth's rotation, making our days longer at a rate of about 2 milliseconds per century. It's a beautiful example of conservation of angular momentum. The total amount of spin in the Earth-Moon system stays the same, but it gets redistributed between the two bodies over time. The Moon gains orbital energy and moves farther away, while Earth loses rotational energy and spins more slowly. But this dance can't continue forever. Eventually, billions of years from now, Earth and Moon will reach what astronomers call tidal locking, the state where both bodies always show the same face to each other, like cosmic partners who've become so synchronized they mirror each other's every move. When this happens, Earth's day will equal the Moon's orbital period, about 47 of our current days. The Moon will appear to hang motionless in the sky above one hemisphere of Earth, never rising or setting, while the other hemisphere will never see it at all. It will be like having a permanent full moon for half the planet, and eternal new moon for the other half. This tidally locked state represents a kind of gravitational marriage, a stable configuration where both bodies rotate and orbit in perfect synchrony. Many other moons in our solar system have already reached this state with their parent planets. Pluto and its largest moon Charon are tidally locked to each other right now, forever showing the same faces like eternal dance partners frozen in an intimate pose. But even this stable arrangement won't last forever, because there's a much larger player in this cosmic drama: the Sun. Our star has been growing slowly brighter throughout its lifetime, and it will continue to do so as it ages. In about 1 billion years, the Sun will be roughly 10% brighter than it is today, enough to boil away Earth's oceans and create a runaway greenhouse effect that will make our planet uninhabitable. The Earth-Moon system will still be dancing their tidally locked waltz, but they'll be doing it in an increasingly hostile environment. But the real dramatic finale comes much later, about 5 billion years from now, when the Sun begins to run out of hydrogen fuel in its core. Like a campfire burning down to embers, our star will start to swell into a red giant, growing so large that its outer layers will extend past the orbit of Mercury, and possibly even Venus. This is where our love story takes its most poetic turn. As the Sun expands, it will become cooler on its surface but much more luminous overall. The increased solar radiation will heat both Earth and Moon to temperatures that would melt lead. Any remaining atmosphere on Earth will be stripped away, and both worlds will become molten balls of rock orbiting inside the Sun's extended atmosphere. But here's the beautiful part. Even in this hellish environment, Earth and Moon will likely remain together. The expanded Sun will create drag on both bodies, causing their orbits to decay, but they'll probably spiral inward at similar rates. They're so gravitationally bound to each other that they'll face this final trial as partners, just as they've faced everything else for billions of years. There are several possible endings to their story, and each one has a different kind of poetry to it. In one scenario, both Earth and Moon spiral into the Sun's core and are vaporized, their atoms mixing with the stellar material and eventually being expelled into space when the Sun sheds its outer layers to become a white dwarf. In this ending, the elements that once made up both worlds would drift through the galaxy as part of a planetary nebula, perhaps eventually condensing into new worlds around younger stars. It's a kind of cosmic reincarnation, death leading to rebirth on an unimaginable scale. In another scenario, the Earth-Moon system might survive the Sun's red giant phase, though both worlds would be thoroughly transformed by the experience. They would orbit a white dwarf star, the hot, dense core that remains after the Sun sheds its outer layers, in a cold, dark universe where the primary source of heat comes from the slow cooling of their parent star. In this frozen future, Earth and Moon would be tidally locked, not just to each other, but to their orbital period around the white dwarf. The same faces would always point toward each other and toward their dim star, creating a configuration of perfect gravitational harmony. They would slowly cool and solidify over trillions of years, eventually becoming cold, dark spheres, orbiting an equally cold, dark stellar remnant. But even this isn't the end of the story, because the universe itself is evolving on timescales that make the Sun's lifetime seem brief. Over truly vast periods, we're talking about 10 to the 100th power years, a number so large it defies comprehension. Quantum effects will begin to take over. Protons, the building blocks of atomic nuclei, are thought to decay over these unimaginable timescales. Eventually, both Earth and Moon would simply evaporate, their atoms breaking apart into elementary particles and energy. Even black holes will eventually evaporate through Hawking radiation over periods measured in 10 to the 67th power years for stellar mass black holes, and much longer for supermassive ones. In the ultimate fate of the universe, all matter will be converted to energy, and space itself will continue expanding and cooling until it reaches a state of maximum entropy, a cold, dark, empty expanse where no further work can be done, and no further stories can unfold. But here's what makes this cosmic story so meaningful. For almost the entire span of time that complex structures can exist in the universe, Earth and Moon will have spent it together. Out of the roughly 10 to the 100-year lifetime of a universe capable of supporting complexity, they will have been companions for perhaps 15 to 20 billion years. A significant fraction of forever, at least as forever can be meaningfully defined. Their gravitational bond, forged in the violence of a planetary collision over 4 billion years ago, will prove to be one of the most enduring relationships in the cosmos. They will have influenced each other's evolution, protected each other from cosmic hazards, and maintained a delicate dance of orbital mechanics that allowed life to flourish on one and provided inspiration for that life to reach toward the other. When we look up at the moon tonight, we're seeing more than just a celestial object. We're seeing Earth's partner in one of the universe's greatest love stories. Every phase, every tide, every stabilized wobble of our planet's axis is a reminder of this ancient partnership that began before life existed on Earth and will continue long after the last star has burned out. The moon doesn't just control Earth's tides and stabilize its rotation. It has been Earth's companion through every moment of our planet's mature existence. It has watched over the rise of life from simple chemicals to complex ecosystems, from single cells to conscious beings capable of looking back and understanding their shared story. In a universe that can seem cold and random, the Earth-Moon system represents something profound, a gravitational relationship that has created stability, enabled complexity, and allowed for the emergence of beings capable of love, wonder, and the desire to understand their place in the cosmic story. And perhaps that's the most beautiful control the moon exercises over Earth. Not just the physical influence of tides and rotation, but the inspiration it provides to life that evolved under its influence. Every time humans have looked up at the moon and felt wonder, every time we've used it to mark time or navigate the seas, every time we've dreamed of reaching it or written poetry about its beauty, we've been responding to billions of years of cosmic partnership. The moon has shaped not just Earth's physics, but Earth's dreams. And in the end, that might be the most profound way one world can control another. Not through force, but through the irresistible pull of shared destiny and the promise that, whatever the future holds, they'll face it together. As we drift off to sleep under moonlight tonight, we can rest assured that this ancient dance will continue, step by step, orbit by orbit, until the very end of time itself. And in that continuity, there's something deeply comforting, a reminder that some bonds are strong enough to last from the birth of worlds to the final cooling of the universe itself.